if C is greater than or equal to A, so C is greater than or equal to A, and D is greater than or equal to B, then I want to prove that AB plus CD is greater than or equal to BC plus AD. So I want to first examine the expression that I can get when I subtract the right hand side expression on the left hand side, like, because it seems to be factorized. So that must be AB plus CD minus BC minus AD. And this could be factorized by factoring out the B for AB minus BC, which is equal to B times A minus C. And factoring out the D for the same negative D, that will leave the same term, A minus C. So B minus D, B times A minus C minus D, A minus C. So if I factor out A minus C, then it will give me A minus C times B minus D. And we know that A minus C, as C is greater than or equal to 0, C is greater than or equal to A, there's A minus C would be negative or 0. And same for B minus D. So it will negative times negative will be positive, or both of them, either of them can be 0. So that could be 0. So I can prove that these are positive or 0. There's AB plus CD minus BC minus AD is greater than or equal to 0. So that gives me AB plus CD. This gives me the original statement.
What I'm going to see second time as suggested, which is okay, is probably easier to try and show that this is positive. So I'm going to put a question mark there, because that's what I'm trying to show. So I've said that this is often the best way of tackling these sorts of questions. This is not actually my favourite method of doing this question. So I'm going to start by trying to show this is positive. Okay, I'm going to rearrange these bits of bits. So I've just moved some of these bits around. Okay, I'm going to take out a factor of B here, A minus C. I'm going to take a factor of D here. Okay, C minus A. I want to show that that is positive. I have got what is looking like a common factor, but these have got a different factor of -1 going on. I know that C is bigger than A, so actually I'm going to rewrite this as D, C minus A minus B, C minus A is bigger than equal to 0, and then I can do some more factorising. C minus A bigger than equal to 0, and this is true as D is bigger than equal to B and C is bigger than equal to A. So that is one way of doing it. Once I've done that, so that was when I did this question to begin with, because I was trying to do exactly what my advice is. I then noticed that this line here, actually I can get to from what we're told. So we know, this is the second method, which lots of people suggested, I think it's actually slightly nicer. We know that C minus A is bigger than equal to 0, and we know that D minus B is bigger than equal to 0. Therefore, C minus A multiplied by D minus B is bigger than equal to 0, and that means that we can expand it and then we get what we want. So that's two different ways of doing the same question. Both are equally good. And as I said, I did it using this method first. And then by the time I got to this point, I realised that actually I could have done it slightly more quickly if I'd spotted that. Okay, I'm going to ask you to think about the next part now, which is
If x is greater than or equal to y, use star to show x squared plus y squared is greater than or equal to 2xy. And if further x is greater than z and y is greater than or equal to z, use star to show that z squared plus xy is greater than or equal to xz plus yz, and deduce that x squared plus y squared plus z squared is greater than or equal to xy plus yz plus zx. Prove that the inequality holds for all x, y, and z. So the first thing I can do is setting c and d as x and a and b as y. I think that will give me the equation we're looking for. And for the second, I think x becomes c becomes x, and d becomes y, and both a and b become z, then I would have the same equation. I would have the same equation that we're looking for. And if I add the two inequalities, like left hand side for left hand side and right hand side with the right hand side, then the inequality sign remains the same. So that will give me the inequality we're looking for. So the problem is that for any choice of x, y, and z, the final inequality must be hold. So we have seen that if x is greater than or equal to y, and that is greater than or equal to z, but this is quite symmetric because we have no other condition for x, y, and z. So even if we change the position in the inequality of x, y, z, that will be the same as x squared plus y squared plus z squared will be remained as y squared plus x squared plus z squared, and that is all symmetric. So even if I change the order of the x, y, and z, that will be the same. So it will hold for all x, y, and z.
This part here. So this first part here, you might have seen done in a different way. So sometimes you might have seen it as x minus y squared is equal to 0. Would be the standard way of doing it. However, in this question, it says use star. So you have to use this to do this part of the question. So any suggestions how we could use star to prove that inequality? Okay, we've had loads of suggestions coming in, which is basically the same thing. X is bigger than or equal to y, so if we let c equals d equals x, and a equals b equals y, then we can plug it straight into this thing here. AB is y squared, CD is x squared, and we get what we wanted. Okay. I'm not going to talk about the next bit because that's not too bad. If we look at this next bit here, we basically do the same thing again, just with I'll get it off there. Just with c equals x, d equals y, and a equals b equals 7. Let's just have a look at the very last bit of the question, which is this bit here. Has anyone got any ideas how we can show that? Somebody's made a suggestion of using x plus y plus z all squared is big equal to 0. Now to do that, you can show that x squared plus y squared plus z squared is big and equal to 2xy plus yz plus zx. The only thing I'm just thinking about at the moment is, does that mean that this has to be, so I'm going to put a question mark here, does that have to be bigger than xy plus yz plus zx. No, I don't think that is necessarily true. What is it?
No. It
So
should be negative. There should be
4 is very
negative.
definitely bigger than or equal to 2, so we can halve it. But -2 is not bigger than or equal to -1. So I think if this was negative, we would have problems with that statement. Okay, so I was just talking about that one, and this is the being careful when things are negative. If things are negative, we can have some problems. So I had lots of suggestions coming in. Some people said do it 3 times with all the different ones. Actually, you don't really need to do much more work at all. So for this one, this is symmetric in X, Y, and Z. So what if we don't have this being true? So if instead we had, I don't know, Z was bigger than or equal to X and Y was bigger than or equal to X, we can just relabel. So if we relabel them, we can then just apply it. So because this is symmetric, then we know that it must hold for all X, Y, and Z. We've all had a few more suggestions coming in as well. Because this question has not actually said hence prove or do this to prove, you can use all sorts of different ways of doing it. I just want to talk about that symmetry. And actually, if you're in an interview and you spot symmetry, that's a really good thing to say. You know, this is symmetric, so I think it holds in that case as well. Okay, I'm going to just go on to another question because I want to give time for us to do more live Q&A at the end. But there are lots of ways to do this question. It's a really nice question. But thinking about symmetry can be a really powerful thing. Okay.
Solve the inequalities. So I think I could multiply x squared on both sides, or I just think of that it's better to draw the graph and the coordinates first, and then think of it, because that will give me some accurate answer, I think. So let me draw each equation first. So the first function that I will look for would be f of x equals negative x squared plus 2x plus 1, and that equals to minus x minus 1 squared plus 2. So this will have the vertices on the coordinate 1, 2. So 1, 2. And it will goes down the negative y direction and passes through the 0, 1. We call the point 0, 1. So it will pass it through here, and the symmetry might have the form like this. And the next thing is the next function I'm going to look for is y equals 2 over x. So y equals 2 over x is a rectangular hyperbola that's on the first and third quadrant. So I don't know whether it passes through or not, but it's obvious that the two graphs will meet and in the third quadrant, as it will goes to it when x tends to 0 from left side, then it will the y tends to the negative infinity. So this shape, and I don't know if it passes through the quadratic graph or not, but it will definitely passes through the point 1, 2, as if I substitute 1 into x, then y would become 2. So it will pass this through here. And the graph would be symmetric in the line of y equals x, so it will also pass it through the point 2, 1. So 2, 1 would be on here. So those two graphs have to meet at 2 points. That means y equals 2 over x will cross the quadratic function twice. So it might have this shape. And we're looking for the interval where the quadratic equation becomes greater than the hyperbola. So that must be between 1 and 2, or x between some point of negative value and 0. So we might have to find that value. I'll take what should I take? A, just number A, x equals A, where x equals A is a crossing point of this equation. So the interval we're looking for is A is less than x, which is less than 0. So at A, we have those points have the same, but I think just intuitively, I think I can put -1 here because I drew a nice graph. So I can just guess. So if I put -1 there, then the left-hand side would be -2, and the right-hand side will have the -2 value for this. That means A equals -1. So the interval we're looking for would be x greater than -1 but less than 0, or x greater than 1 but less than 2. So this would be the answer. And if I have to find the value of A without just guessing, then I'll have to solve the equation 1 plus 2x minus x squared equals 2 of x. So that will give me x squared minus 2x minus 1 plus 2 over x equals 0. And these have the value, these have the solution at x equals 1 and x equals 2. And we can, as x is not 0, we can just multiply x on both sides. So that will give me x cubed minus 2x squared minus x plus 2 equals 0. As we multiplied x on both sides, this could give us this will give us additional solution for this equation. However, which should be 0. However, we have supposed that x is not 0. Well, that was all because that there was a fraction and there was an x on denominator. However, so we have no additional solution through multiplying x on both sides of the equation. So using the fraction theorem, I don't know, remainder theorem. So let this expression be h of x. Then we have known that h of x, h of 1, and h of 2 would be 0. So we have that x minus 1 times x minus 2 times x minus a would be 0. And just by considering the constant term, which will be made by -1 times -2 times -a, that means 2a. So 2a must be, -2a must be 2. So -2a must be 2. That means a equals -1.
Another question. So this isn't the whole set question, it's only part of it. Solve the inequalities, and this is just the first inequality. 1 plus 2x minus x squared bigger than 2 over x. So in the chat, are there any suggestions for what we could do? I'm going to talk for the two methods that I used, and then I might try using a third method which has been suggested and see how that works. So my first way of dealing with these inequalities is to draw a graph. So I can sketch, but if I actually turn this onto the draw thing, I can sketch 2 over x, that's dead easy. When we come to graph sketching as a webinar, I will talk a bit about graphs that we might expect you to be able to just draw. 2 over x we'd expect you to be able to just draw. Y equals 1 plus 2x minus x squared. Well, okay, I know it's a sad parabola. I know it's got to go through 1 here. So it might look something like that. I don't know yet. It might not hit 3 times. It might just touch. Or it might hit 3 times. So I'm going to draw it as 3 and see what happens. So I'm now going to look at these points of intersection. So at the points of intersection, 1 plus 2x minus x squared equals 2 over x. Now it's an equal sign. I can multiply by x very happily. Not be a problem. Minus x cubed equals 2. X cubed minus 2x squared minus x plus 2 equals 0. If you stick in x equals 1, you get 1 minus 2 minus 1 plus 2. Okay, so x equals 1 is a solution. Factorization is your friend. The factorization theorem is useful. It's nice when I actually pick questions that work together. So x cubed minus x squared, I need minus 2x squared, so that's minus x. That gives me plus x, I want a minus x, I'm going to put in a minus 2, and that gives me minus 1 times minus 2 is 2, that's helpful. X minus 1, x minus 2, x plus 1. Okay, so I know that this point is at minus 1, this point is at 1, and this point is at 2. By the way, when you are doing graph sketching in the interview and your graph goes a little bit wrong, just say, oh, actually, it shouldn't do that. It should actually look like this. And that is absolutely fine, especially if you're using a tablet and it gets a little bit hard to actually show where things are taken. Okay, so we want, actually, I'm just going to put it in red. Right, we want the cubic, not cubic. We want this side, which is the bit in red. Apologies if you can't see the difference between red and blue. We want this side to be higher than the 2 over x. So we're looking at this region here. So x is between 2 and 1. For some reason, my pen is now a different colour. And then we want this region here, which is x is between minus 1 and 0. Okay, so that's the way I would approach this question. I'm a lot happier with using graphs. The second way you can approach it, which has been suggested, is to actually consider 2 different cases. So you can consider the case when x is bigger than 0, and then the equality becomes minus x squared bigger than 2 over x. That's the same thing again. Oops. If you multiply by x, because x is positive, it stays the same. Now, the only problem with doing it like this is you need to keep in your head that you're only looking for solutions here which obey x bigger than 0. And when you sketch the graph, you're only looking at the x bigger than 0 bits if you sketch the graph. That should be a cube, that should be 2. And then you can also look at x less than 0, where the inequality becomes x plus 2x squared minus x cubed is less than 2. Oops, it's meant to be 2, that went a bit weird. Now it's gone red. And then you sort of split them into 2 different things. There's been another lovely idea, which is factorizing the inequality and then doing the, oops, I've got the wrong page. Factorizing the inequality and then looking at 2 different things. So I'll just try and write down what that was. So someone has suggested rewriting it as 2 over x minus 1 times x squared minus 1 bigger than 0, and then sketching both parts. And a lot of other people have suggested multiplying that by x squared. So if you multiply both sides by x squared, you don't need to worry about the inequality swapping. You've then got a quartic, which is a bit nastier than the cubic, but that's a really nice way of doing it as well. So if you multiply by x squared, because it's positive, you're happy, and you get x squared plus 2x cubed minus x power 4 is bigger than 2x. So one of the things you might like to think about after this webinar is just trying some of those other things before. Yeah, so that wasn't quite what I meant. Trying some of these other ideas and seeing if those will work. So there are lots of different ways to do this question. That's why I really like it. I'm going to press on, but have a think about that question and perhaps try some of the other methods and just check they all give you the same answer. Sometimes I get a bit distracted and try and actually do every single method. I'm going to do that today. But last question I'm going to think.
So, firstly, I've noticed that squaring both sides doesn't matter, doesn't change the inequality sign, as both of them are positive. So I can just write that 3x plus 10 equals 10 is greater than x plus 4 plus 2 times square root of x plus 4. And then just moving them, just moving the old expression except for the square root to the left hand side. Then I can check if the left hand side expression has a positive or not, and if they're positive, then I can just square both sides, and if they are negative, then negative can't be greater than positive square root, so we don't need to consider it. So what I'm saying is 3x plus 10 is greater than 4 plus x plus 4 plus 4 times square root of x plus 4. It will give me 2x plus 2 is greater than or equal to, just greater than 4 square root of x plus 4. And as x is greater than or equal to negative 10 over 3, so that means as this gives at the negative 10 thirds, 2x plus 2 is equal to is negative. So y equals to x plus 2 looks like this shape, where passing through the point 0, 2 and passing through negative 1, 0. So when x is greater than negative 1, then that means we can square both sides without changing the inequality sign. So it will give me x plus 1 squared is greater than greater than 4 times x plus 4. And when x is when x is less than or equal to, when x 2x plus 2 becomes 0, then that means x plus 4 also have to 0, because they're just like no. When 2x plus 2 equals 0, then square root of x plus 4 should be less than 0, but that doesn't make sense, as square root will result in 0 or greater than 0 value. So we are confined to the interval that x is greater than negative 1. So in this interval, we have to solve this inequality, which will give me x squared minus 2x and minus 15 is greater than 0. So that will give me x minus 5 times x plus 3 is greater than 0, and this means that x is greater than 5 or x is less than -3. But as I said before, we are only looking for x greater than -1. So the actual solution would be x is greater than 5. So this is my first solution. And the second thing is just drawing the graph, just sketching the graph. So if I consider y equals square root of 3x plus 10, it will start at the point x equals at the point -10 third 0. So and it will start at negative 10 thirds and will slowly increase as x tends to increase. As x increases, y will also increase, but slowly, and passes through the square root of 10 at y-axis. However, if I consider y equals 2 plus square root of x plus 4, it will start on where x becomes -4, as it's the domain of this square root function, and we can know that this function will increase more slowly than y equals square root of 3x plus 10 does, because 3x plus 10 has a steep, higher gradient than x plus 4 does. So it starts on the place where x becomes -4, but we'll have the y values of 2 as when the square root sign has 0, then y becomes 2. So here. And it will, as x increases, y also increases, but slowly. So it will increases, but slowly. And will passes through the 4 and y-axis. So it doesn't meet where x in the second quadrant. So they will eventually meet at the first quadrant. So I'll take number A, where such that those two graphs meet at x equals a. So let's say 3a plus 10, square root of 3a plus 10 equals 2 plus square root of a plus 4. Then I can just square both sides. So that will leave me as with 3a plus 10 equals 4 plus a plus 4 plus 4 times square root of a plus 4. And if I subtract a plus 8 on both sides of the equation and divide them by 2 and square it, then we will have the same equation like we did before. A plus 1 squared equals 4a plus 4. And if I subtract the right hand side on the left hand side, then it will give me the quadratic equation, which would be a squared minus 2a minus 15 equals 0. And that will be, the solution will be a equals -3 or a equals 5. Because as we noted before, a can't be negative value, so the solution we're looking for would be a equals 5. So a becomes 5. And the interval we're looking for would be where the left-hand side becomes greater. That means x must be greater than 5.
And then we'll do a bit about where you can find problems. So this is the second part of this question. And I'm just going to show you the solution. And I've got two questions for you here. So this is the solution I wrote down. My first question is, how do I know that this solution at the bottom here is incorrect?
Because the solution you have shown me is just solving the equation, but we know that wait a minute. So actually, when we substitute those values in the first original equation, then when x equals -3, it will not be the equal. So x equals -3 is incorrect, and when you square both sides, you will have one more solution, but well, where do you make this mistake? So you have squared both sides twice, and the thing is that I believe that the problem that I have is I have believed that when you square both sides of the equation, then you will have the additional root, or that you double the number of the roots that you originally have. But the thing is that you have squared both sides twice, but why is there just one additional so when you first square it, then it becomes like, wow. So I think that when you first square it, we're just looking for so the graph we have drawn here would be like when you first square it, then that means square root of 3x plus 10 could be square root of 3x plus 10, or minus square root of 3x plus 10. So it will become symmetric about x equals 0. But as there exists x plus square root of x plus 4, it will not become so the y equals square root of x plus 4 will not become symmetric as we expected. But and when you at your second square process, then square root of x plus 4 will become symmetric about y equals 2, and that makes one more additional solution, meeting points at where meeting point except for x equals a, that becomes x equals -3. But I don't know how to figure out. So and my reasoning is not correct, as I can substitute x equals -3 at the second equations, and that gives me contradiction, because left hand side will be 1, while right hand side will be 4 plus 4 plus 1, so 9. So they're contradiction. So you made a mistake when you go to the second expression, but I don't know why. So the squaring has the significant problem as you thought, and the problem I'm thinking of is why there was no any problems with when you square both sides of x plus 1 equals 2 root square of x plus 4. So, wow. So, the possible way I was figuring out this is that even if I square once again, where at of the equation x plus 1 equals 2 root square of x plus 4, they made the same additional incorrect solution. That would be my -3. So it seems there was no mistakes on when we go to the fourth six go from 4 sentence to 5 sentence. But I don't know how to how to prove this or how to explain this. I don't know how to put this word. Square root of. So, so the reason that you must not square both sides means that if you square both sides of the equation, then you will make, for example, on the left hand side, you will have the expression that could be square root of 3x plus 10, but also the square of minus square root of 3x plus 10. And that also means that when you square the right hand side, then you will have the expression on the right hand side that is square of the plus 2 plus square root of x plus 4, but -2 minus square root of x plus 4, because both square root of which they will have the same square values, and that could be also derived from the second equation. But here's the thing: when you so I just came up with that when you square both sides of the equation on the fourth equation, then x plus 1 squared could be squared value of x plus 1, but -x minus 1, but they also, both of them have the same, no, so x plus 1 looks like this, and square root of 2 times square root of x plus 4 looks like this. Right? And when you square root both of them all together, then x squared plus 2x plus 1 could be square root of x plus 1, but also square root of minus x minus 1. So it will look like now we have to graph two graphs which is symmetrical in the x-axis, but when you square 2 times square root of x plus 4 and you get 4x plus 4 times x plus 4, then that could be the square root of both of either of 2 times square root of x plus 4, but negative 2 times square root of x plus 4. So that will be even if you have one more root, the root that you had another side doesn't become the additional root, as they're all symmetrical in about x-axis, so they will have the same x values when they meet. So you shouldn't have do that square twice. So both of them were incorrect.
So how do I know that this is incorrect? Yes, somebody has just said it's not an inequality. Yeah, that is very true. I don't know why I put equal signs all the way down there, but yes, it's not an inequality. That's true. There's also something else a little bit wrong with it. One of the issues is that this x equals minus 3 gives us root 1 is bigger than 2 plus root 1, which is dodgy. Can anyone spot where it's gone wrong or what we needed to think about? So, I mean, these bits here are fine when we consider this restriction. So squaring both sides is actually where it went a bit dodgy, but actually the first squaring was fine. So some people have said the second time you square both sides, yeah. So at this point here, this line here, we must have x bigger than minus 1 in order to square both sides there. So the square root is defined to be the positive square root of something. So that's the point where it went wrong. So have a look at this question. It's a nice question. It's 2001 set 1 Q1. It's quite a nice question to work through. We've got about 15 minutes left. I'm going to talk a little bit now about where you can find stuff to practice on.
What? I don't think so. 3x plus, no, not here. So 0, no problem. Then what about this? X plus 1 and negative x, negative 1. To square root of x plus 4, negative 2 square root of x plus 4.
Those. So some of the ideas for practice. First of all, the STEP support program. Now, a lot of the stuff I've written, so I'm quite. Some of the ideas for practice. First of all, the STEP support program. Now, a lot of the stuff I've written, so I'm quite keen on it. I'm just going to turn off the chat for a second so that I don't get distracted. But the foundation assignments that I've mentioned there are, I think, particularly interview-like questions. So foundation assignments 1 to 6, number 10 and number 11. And I'm going to send you this information through with the email tomorrow. So those modules there have got some interview-like questions. You can also use something called the STEP database. That has got all of the STEP questions in it. If you search for C1, it will give you the questions which are based on the first bit of A-level maths. So these are questions which could be asked at interview because basically everyone's done that bit of maths already. But they're still set questions, so they still require you to think. So that C1 tag, that comes from the old A-levels, back when A-levels were modular. So C1 was just the first module, it means core one. But if you just type in C1, it will get you those STEP questions which are based on the first bit of the A-level specifications. I've got 2 links here to some Enrich problems. So part of my working week, I work on some post-16 problems for Enrich. The first question here are some interesting equations. There's lots of symmetry going on that you can utilise to get into the questions. And the second one is a little bit about logic, so being careful about implications. X equals 2 implies that x squared equals 4, but x squared equals 4 does not imply that x equals 2. So it's that sort of thing. I've suggested another STEP question here. So 2013 step 1, question 1. And the last question I've got here, this comes from the Mr. Bowler's problem solving booklet. And what I'll do at the start of the next session is I'll talk about this question. It's a really nice question, I think. So this is one question from Mr. Bowler's problem-solving booklet. It's sometimes also called the TVO booklet. Now, that has a selection of about 150 interview-like questions. The one thing I'd say about it is it's an excellent booklet. It's got some brilliant solutions. The only slight problem with it is it doesn't quite recreate an interview in that you haven't got an interviewer there giving you some hints. So for this question here, you might be able to do it straight off. In an interview situation, the interviewer might be giving you some hints if you're not quite sure how to get started. So it's a really good booklet, but just be aware that you working on those questions, which are very short questions, isn't quite the same as actually being in an interview. And I think that was one of the Q&A, was talking about the TVO booklet. I will provide you a link in the email, which will take you straight away. You can download that. I think it's on the Dr. Frost Maths website. Okay, I'm going to stop sharing again.
Or I didn't really like it, and we did like 2 questions in the stats one. But don't take that to heart. Don't take your feelings to heart on that matter. But I was going to jump into this question, which says, I truly really hate stats. And that's how it starts. It ends with, if they ask me for a versity, can I just ask for another question? And I would not recommend doing that. The point of the interview is not to test you. They've got stats, they've got errors. Of course they want to assess you in some manner, but it's important to them that they can see your whole process. They can see you having a go. And the worst thing, therefore, to do is say, I'm not going to have a chance at that. Don't even bother asking me. Give me something else. You're not. And of course, there will be areas of math that you don't like as much, areas that you're not so good at. And I don't know, maybe you want to be honest, maybe you don't want to be honest. I probably would be. I'd probably say, okay, I'm not so much of a fan of stats, but I will give it a go. I don't know if that's good advice. But
I would probably just get stuck into it and see what happens.
Probably just, yeah.
Don't ask another question. So on the back of that, I would be surprised if you were asked any vectors questions in an interview. But vector seems to be after stats and mechanics, vector seems to be the next thing that people say they don't like. But with
yes, maybe you don't want to be honest. I probably would be. I'd probably say, okay, I'm not so much of a fan of stats, but I will give it a go. I don't know if that's good advice. But
I would probably just get stuck into it and see what happens.
probably just
Don't ask another question. So on the back of that, I would be surprised if you were asked any vectors questions in an interview. But vector seems to be the after stats mechanics, vector seems to be the next thing that people say they don't like. But with anything, if it's something you don't think you've covered, then that's fine to say. But I think for the stats questions, a lot of the time it's almost GCSE tree diagrams type ideas taken a bit further.
And I was thinking as well, don't make up your mind so early on a whole bunch of mathematics. Like you may end up enjoying it a lot more, even if you really makes you so different.
The flip side, if you found the interviews really hard, that also doesn't mean that you're not going to.
I was going to jump into another question, but again, makes you so different. Pure One I quite liked the fact, even though it doesn't have anything to do with how well your interviews went, I quite like the fact that I went through a fair few questions in a short amount of time. And I feel quite good about that. And therefore, I didn't really like it when we did like 2 questions in the stats one. But don't take that to heart. Don't take your feelings to heart on that matter. But I was going to jump in with this question, which says, I truly, really hate stats. And that's how it starts. It ends with, if they ask me probability, I truly don't take that to heart. Don't take your feelings to heart on that matter. But I was going to jump in with this question, which says, I truly, really hate stats. And that's how it starts. It ends with, if they ask me probability, can I just ask for another question? Stats. And that's how it starts. It ends with, if they ask me probability, can I just ask for another question? And I would not recommend doing that. The point of the interview is not to test you. They've got A-levels. Of course they want to assess you in some manner, but it's important to them that they can see your whole process. They can see you having a go. And the worst thing, therefore, to do is say, I'm not going to have a chance at that. Don't even bother asking me. Give me something else. You're not. And of course, there will be areas of math that you don't like as much, areas that you're not so good at. And I don't know, maybe you want to be honest, maybe you don't want to be honest. I probably would be. I'd probably say, okay, I'm not so much of a fan of stats, but I will give it a go. I don't know if that's good advice. But
I would probably just get stuck into it and see what happens.
Probably just,
Don't ask another question.
I don't know if that's good advice. But
I would probably just get stuck into it and see what happens.
Probably just,
Don't ask another question. So on the back of that, I would be surprised if you were asked any vectors questions in an interview. But vector seems to be the after stats mechanics, vector seems to be the next thing that people say they don't like. But with anything, if it's something you don't think you've covered, then that's fine to say. But I think for the stats questions, a lot of the time it's almost GCSE tree diagrams type ideas taken a bit further.
And I was thinking as well, don't make up your mind so early on a whole bunch of mathematics. Like you may end up enjoying it a lot more, even if you really hate it now.
Someone's asked, are there any devices that I'd recommend you buy for online interviews? If you're going to buy anything, I would probably buy a relatively cheap graphics tablet. So I think you can get them for about £30 off Amazon. But you might want to just hold fire and see what your college says first. Yeah. I think some colleges also have a scheme where if you are in receipt of free school meals or some other benefit, that they will buy you a tablet. So if at any point your college wants you to have particular equipment and you're worried about buying it, contact the college. But if I was going to buy anything, a cheap graphics tablet, they all work pretty much the same way. I've got about 3 now, and just because I got extra ones for giving them out to people to practice on. And they all work very much the same way. On back of that, somebody asked, is the dog okay? Yes, she was absolutely fine. It was a relatively small glove that he ate, and he's also eaten lots of socks as well. But he's a big dog, so they just sort of go straight through. So that was answering that question. Any recommended brands for tablet? A cheap one of Amazon. This one, WACOM1, but a relatively cheap one is absolutely fine. Right. Are anything else that the mentors want to pick up on? And we do have loads and loads of questions which we haven't had time to do.
There's one that says if you get called from a college that doesn't do pre-interview tests, the one that does where you have to do the test, yes. If you get called to a college, it's the same as if you applied to that college, basically. So you'll be required to do their tests and their interviews.
Okay. Oh, somebody suggested a couple of different tablets in chat. So somebody said XP Pen, Wacom One, and Wacom Intuos. So there you go. So there's a few suggestions there. Somebody said, does the step is the same as the interview, or should I sit it in on a different date? Step is something completely different. So we have 15,000 to 18 a different date. Step is something completely different. So we have about 15,000 to 18. Sorry, not 15,000. 1,500 to 1,800 applicants. We make about 500 to 550 offers, and then there's about 250 places. So what happens is that after interview, there's about 500 offers go out. We then ask people to sit step, which then it's not the 250 best people in step, but we use step to then select the 250 people in the end. After the offers have gone out, I'll be running another webinar about step and about what some of those things mean. So I will cover that before. Okay, I make it 8:30. I'm about to completely lose my voice. Next session, we're going to talk a little bit about calculus, but I'm also going to keep talking about technical equipment. I'm going to try and pick up as many questions as I can. I'm going to look through all the questions that have been asked today and try and summarise some of those at the beginning of the next session. I want to say thank you to all my mentors, and I'll
how many ways can you arrange each of the digit 1 to 6 to create distinct 6-digit numbers? So we just want to place 6 numbers to 6 places of each digit, and that means we just can use permutation. So 6p6, that means 6 factorials. So, and we know that 6 factorials is equal to 720. So there would be 720 numbers next to each other and in that order. So I want to make a group of 1, 2, 3 and arrange that group with the the others number 4, 5, 6. So there will be a group, the group, and 4, 5, 6. So if I consider that group as a number, then we have to arrange 4 numbers. So that means similarly we can use 4 factorials. So that will be, they will be arranged. However, in that group there will be some arrangement in order. So we can think of the arrangement inside the group as 3 factorials. So that will be 4 factorials times 3 factorials. So it would be 4 factorials equals 24, 3 factorials equals 6. So that would be 144. Okay, ChatGPT. Okay, I'm going to talk about I'm going to prepare for the mathematics interview for the university admission, and I want you to revise my answer correctly. I mean, I'm an international student, so I don't know how to speak mathematical concept or mathematical solutions in English properly. That is, so I don't know mathematical expressions, correct expressions that is naturally and commonly used by native speakers. So what we're going to do is that I'm going to give you a question and the solutions of my thinking, and then when you receive that solution, you will have to revise my answer if there is some awkward expressions for it. So, but you have to note that the answer or the process I take doesn't matter. So even if the answer is incorrect, or even if the approach is not efficient or not correct, you don't need to change it, but you just need to deal with some expression. So how I pronounce it, not pronunciation, but how I read the mathematical expressions, or how I explain the mathematical concept or mathematical circumstances. So you need to help me to use only natural and commonly used expressions. You got it? In how many arrangements does 5 occur before 1? So I just believe that there would be 2 cases when 5 occur before 1, or 1 occur before 5, and there's no any other options. So, and considering that all the digits, there are no any conditions given for each number from 1 to 6, and they're all symmetrical. So the case that 5 occur before 1 and 1 occur before 5 would be the same. So the number of cases will be divided into 2. So the whole number of cases is as the whole number of cases equals to 720. Does the arrangement that 5 occur before 1 will have the number of 360. What does it mean? How many distinct 6-digit numbers are there in which all of the digits 1 to 5 appear? Okay, thank you for your revision, but I hope you to provide me with a pinpointing which expression I use is incorrect or unnatural. So you don't need to correct all the answer I gave you, but just pinpointing which expression do I need to correct or make it more natural. How many distinct 6-digit numbers are there in which all of digits 1 to 5 appear? All of digits 1 to 5 appear. So I can think of in how many arrangements does 5 occur before 1? How many distinct 6-digit numbers are there in which all of the digits 1 to 5 appear? And additionally, I want you to provide the pinpointing or correction for that I made a mistake or a natural expression. So you don't need to revise sentence to sentence, but you just need to give me some correction for the expression, only for the expression that I made some mistakes in natural expression or mathematics. Okay, so here's the answer. So I can come up with two approaches to these problems. So firstly, the first approach is that considering all the numbers, all the 6-digit numbers that contains 1, 2, 3, 4, 5, respectively, and thinking of 1, 2, 2, 3, 1 2 1 3 1 4 1 5 and 2 3 2 4 2 5 3 3 4 3 5 4 5 and thinking of 1 2 3 1 2 4 1 2 5 and so on, and like I can add the number of cases where I said just one number, and I can subtract the number of cases of where I was considered two numbers and add the three numbers, subtract the four numbers and five numbers, or something like that. But I don't think this is a good idea. So so I want to think that there would be 5 digits at least. So among the there, I want to divide this situation into two cases. Like there are only digits 1 to 5 appear, and there one more additional number that appear in the 6-digit numbers. So the first cases where 1 to 5 appear in 6-digit number, it means that there are number among 1 to 5 that appears twice. So we need to choose which number to be appear twice, and the number of cases that of choosing the number that will be appear twice is 5, as 1 to 5. So we need to multiply 5 first, and then we need to arrange those 6 numbers in order. So that would be 6 factorial. But if like the two numbers which are the same, like for example 1 1 2 3 4 5, and they will be counted double. I mean, if 1 2 1 3 4 5 and 1 2 1 3 4 5 will be counted twice. So I need to divide that by 2 factorial. So it must be 5 times 6 factorial divided by 2 factorial. So that is the first case. And the second case is there are only one numbers of 1 to 5, and there are one more additional number among 6 to 0. But it's quite hard to think of the 0, because when the 0 goes to the first digit, then it won't be the 6-digit numbers. So I want to consider about 0 just later. So there are 6 to 9. So there are 3 numbers that can be chosen. So we need to multiply 3 first, and then we will arrange them in order. So that will be 6 factorial. And there is no double counted or triple counted numbers. So that's all for this case. And last thing is for when 0 appear in the 6 digit, then we need to subtract the case when 0 comes to the first digit. So first we just randomly arrange all the numbers like that, which will give us 6 factorial, but we need to subtract the number of cases where 0 comes to the first digit. So that would be 0 is fixed on the first digit, so we need to arrange the other remained numbers on 5 digits. So that would be 5 factorial. So the number of cases which contains 0 in the 6-digit numbers would be 6 factorial minus 5 factorial, which is 5 times 5 factorials. So this is all the cases we're looking for, and now we have to arrange. No, we have to add all of these cases. So first, I have 5 times 6 factorial over 2 factorial plus 3 times 6 factorial and 5 times 5 times 5 factorial. So and that will be taking out the 5 as a factor, 5 factorial as a factor, then I'll have 15 and 18 and 5. This, which will give us a 38 times 5 factorial, and that will be 5 factorial is 120 and 338. There's 76, 38, 06, 5, 4. So there would be 4,560 numbers. I have devised 2 approaches to address this problem. Consider all 6-digit numbers containing, and I can calculate the total by adding the cases which one specific number and subtracting those with 2 specific number, adding cases with 3 numbers, subtracting those with 4, and so on. In the first case, only the digits 1 to 5 appear. The 5 factorial is 420, and multiplying it by 38 gives us 4,560, plus 5 times 5 factorials. We need to subtract the cases. We need to subtract the cases where 0 is the first digit. It's challenging to consider the digit 0. Only one occurrence of the digits 1 to 5. Only one number. Only one occurrence of the digits 1 to 5 and one additional number from 6 to 0. In cases where 2 numbers are the same, the number of ways to choose the digit that appears twice is 5, corresponding to digit 1 through 5. In the first cases, so the number of ways to choose the digit that appears twice is 5. As there are no repeated element amongst the digit 1 to 6, the second part is answered by blocking 1 to 3, blocking 1 to 3 as a single element, and the third part is simply half of the arrangement. The last part is more difficult, and care is needed to ensure certain arrangements are not counted twice. The 6 digits can be any of 0 to 9, but the cases where the extra digit is 0, the cases where the extra digit is 0 to 5 must be considered carefully. Okay, so there are 151 problems, and I think I'd have like 20 days until by the interview day. So I need to do like 10 questions or 7 questions a day. Okay. The power set is formed from all subsets of a given set. So here's the question. The power set is formed from all subsets of a given set. If a set contains an element, what is the cardinality of its power set? How many subsets contain a given element x1? So here's the answer. So the cardinality of its power set means that the number of the all subsets in the set. So that contains an element. So that means we just think of the set first, that subset. So let's generate this subset in this process. Like we can choose just individually about one element like that can be included into the subset or not, and that will be choose individually. So I have 2 cases for that single element to be included or not, and the next element that can be included or not in the subset individually. So there are 2 cases for 2 cases, and the third will have the same 2 cases of included or not. So all the n elements possess 2 cases of to be included or not to be. So that we need to multiply 2 for n times, and that will be 2 raised by the power of n. So the cardinality of its power set will be 2 raised by the power of n. How many subsets contain a given element x1? So let's say, so we have firstly considered that x1 can be included or not, but we just need to now consider that x1 should be included. So there would be just only 1 cases for that element. So we need to multiply 1 instead of 2. So that means, and another cases will be the same because they will be determined individually. So there would be 1 less 2 in the cardinality. That means we will multiply 2 for n minus 1 times. Which means that the cardinality of power sets would be 2 raised by the power of n minus 1. And this is quite obvious, as there would be subsets which contains x1 and which does not contain x1. So they would be divided into 2. However, the other subsets, the other elements will be determined to be included or not in the subsets individually. So the number of subsets, those 2 subsets would be the same. So that means we can just divide the cardinality of the subset power sets by 2, which will give us 2 raised by the power of n minus 1. The size of the power set is simply a power of 2, as its element either included or excluded within its subset. The number of subsets containing a given element is the previous power of 2, as we can imagine forming every possible subset without the giving element, and then include it in it. the cardinality of the power set refers to the total number of the subset within the set containing an element. This requires considering each subset of the set. For each element, we individually decide whether to include it in a subset or not. So for each element, we individually decide whether to include it in a subset or not. Similarly, for the next element, there are two possibilities, inclusion or exclusion. This pattern continues for each element. Thus, each of the n elements has two options to be included or not. Therefore, we multiply the two options n times, resulting in 2 to the n. This a more concise way to say this is, initially we considered whether x1 could be included or not. However, now we must assume x1 is always included. Thus, there is only one option for this element. This results in 1 fewer 2 in the multiplication. Therefore, the number of subsets containing x1 is 2 to the n minus 1. Besides that, the power set is simply a power of 2 as power of 2, as each element in the is either included, as its element is either included or excluded within each subset. The number of subsets containing a given element is previous power of 2, as we can imagine forming every possible subset without the given element and then included in each. Right. If a round table has n people sitting around it, what is the probability of person A sitting exactly k sits away from person B? So, wow. So it is a round, since it is a round table, we can rotate it before everyone sitting there. And even if we rotate the table, it would be all the same as, because of the symmetry. So we can just fix the sit of the A at the top of the circle. Now we can't rotate the round table. And when the person A is sitting on the top of the circle, then I can divide it like two cases for like n could be even or n could be odd. So I just want to think of this as separately, as if n is even number, then half of n. So if n is an even number, then a person B can sitting half of n sits away from A, which counted just once. However, if n is odd, then half of n is would not be integer. So half of n plus 1 could be counted twice, like any other sits. So I just want to draw this in the diagram. If A is sitting on the table top of the table here, then there would be an empty sit. And if n is even, then there would be one sit that that faces A directly. However, if n is odd, and is an odd number, and when A is sitting on the top of the round table, then there would be two sits in front of the A. And now we will consider that for the n, for even number n, we have k less than n half of n. That means B can sit here or here, here. Yes. And there are cases when k is half of n, then there would be two cases. So among, we can just, now every position can be numbered, like 1, 2, 3, 4, 5, 6, 7, 8, 9, and to n minus 1 clockwise starting from starting from A. So each sit has numbered. That means they can just, it's just a permutation of yeah, it's just a permutation. So for n, the total number of cases will be n minus 1 factorial. And there will be 2 if k is less than half of n. However, if k is half of n, then it must be 1 over n minus 1 factorial. For the odd number n, and one more thing, if k is over, so I mean it's greater than half of n, but less than n, then it must be the same, as they can, if like k, let's suppose k equals half of n plus 1, then he have to sit here. However, he also can sit here, as it's n half of n plus 1 far away from A when we consider it anti-clockwise. So it's also 2 over n minus 1 factorial. And when for the odd number n, you don't need to struggle with the half of n, as it doesn't exist, and half of n plus 1 or half of n minus 1 will have the same, just have the same effect. So when k is just for k greater than 0 but less than n, the probability of B sitting on the chair for k sits far from the A would be 2 over n minus 1 factorial. No. K is needed when n is even and k is half of n, because in this case there is only one set that B can take which satisfies the condition going a probability of 1 over n minus 1. In all other cases, there are 2 sets B can take Hence, the probability is 2 over n minus 1. What is the probability that person A sits exactly k sits away from the person B? Given the round table's symmetry, we can assume any rotation of the table results in an equivalent sitting arrangement. Therefore, we can fix person A's sit at the top of the circle. Then there would be one sit directly opposite A. Then there would be one sit directly opposite A. When k is half of n, there would be two distinct positions where B can sit. We can number its position clockwise starting from A as 1, 2, 3, and so on up to n minus 1. This situation can be described as a permutation. For an odd number n, there is no need to consider exactly half of n, as it isn't an integer. This is when k is greater than 0 but less than n. Okay. Here's the next question. How can you maximize the number of regions and straight lines will divide the plane into? What is the maximum in terms of n? What if we replace lines with circles? What does this tell you about Venn diagrams? Wow. How can you maximize the number of regions and straight lines will divide the plane in two? So if there are only one integer, only one line, then it will divide two. And if there are one more lines crossing the line, then it will divide two regions by two. And if there's one more, then it can divide it can cross the other two lines. So we'll make it as there are three areas that L. So there are three regions that L can divide, meaning that it will be added by 3. So if there are 3, so when there is one line, then the region would be 2. There would be 2 regions, and if there are 2 lines, then the maximum areas that is divided into is 4. And if there are 3 lines, then it would be 7 areas. And now consider that. Now we can consider that the fourth line crosses all 3 lines into different points. That means those 3 lines was forming 4 areas by dividing into 3, but this line will divide those 4 areas into 2 by 2. That means we can add 4 areas more. That means for 4 areas, it will become 11. So it means that the increment for each element would be 2, 3, 4. So the increment increases by 1. That means for an for there n lines on the plane, and let's say the maximum area as an, then an equals to n minus 1 plus n. So this is the maximum, and the thing is that how can we have the expression for an? So let's say an minus 1 equals n. So I want to consider that a1 minus a2 equals 2. Well, a2 minus a1 equals 2. a2 minus a1 equals 2. a3 minus a2 equals 3. a4 minus a3 equals 4, and so on to an minus 1 equals n. And if we add all of these equations, all of these inequalities, like adding left-hand side with left-hand side within the left-hand side and right-hand side with right-hand side, then I'll get an minus a1 for the left-hand side, and 2 plus 3 plus 4 plus and so on plus n. That equals to adding I from I equals 1 to n, but minus 1. This we know this n squared plus n minus 2. So half of n squared plus n minus 2 would be an minus a1, and we know that a1 equals 2. Thus, an would be half of n squared plus n plus 2. Yes. What if we replace lines with circles? Okay, so let's observe it first. So well, then you demonstrate a good understanding of the concept. There are just only one. There are only one line. If there is only one line, it divides the plane into two regions. Adding another line that crosses the first one divides each of the regions into two, making 4 regions in total. Each new line can intersect all previous lines, creating additional regions. For example, the third line intersects 2 lines, adding 3 more regions. All of this equality. If we sum these equations, we get a series summing from 2 to n. This discussion is clear. So what if we replace lines with circles? So let's observe it first. Observe the circumstances first. So there's one circle which divides the whole plane into 2 regions. And if I add one more circles to make the maximum regions that are divided, then it will look like this. And we'll make 1, 2, 3, 4 4 regions. So when n equals 1, then when n equals 1, then an would be 2. When n equals 2, and an would be 4. When n equals 3, like this, then the circle will add 1, 2, 3, 4 regions more. So it means that we can add 4 regions more. 8. That means all the circles that we can draw can passes through the circle, or passes through its circles twice. Like if you want to add 1 more circles, then we can do, and each of the intersection should be different. So like this, and the other region would also be divided into 2. That means we can make these area into 2, and these area into 2. So 1, this is 1, but not 1 anymore. Not 1, not 1, but 1 here. Not 1, not 1 anymore, but 1 here. So what should I do? One, 2, 3, 4, 5, 6, 14, 2, 4, 6. Wow, I thought it could be some 2 power of n, but why did it? So I thought when we consider the Venn diagram, that means there are n circles in the Venn diagram, and its divided area means that the elements can be included here or not. So the region of the area must be 2 to the n. Wow. So for the circles, this is the same. We can choose a point where circles can be into its circles or not. So I mean, if I take the circle's name C1, C2, C3, C4, there are 2 to the 4, 2 raised by the 4 cases. Number of cases that the point can be included or not included in its circles. So it must be 16. However, why not? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How can I make it more? Make them more. Why? It has to be. It has to be. It's 16. I don't know why. I don't know how to draw it. But when considering Venn diagram, each element can be included or not included in each circle, and that means we can choose its inclusion and exclusion into its circles for n times, and that means so I want to think of that I want to think of the case that C1 and C2 must be the element that is contained into C1 and C2, but not contained C1 and C2, but not contained in C3, but contained in C4. So what should I do? Wow. Okay, so my answer would be a Venn diagram. When the Venn diagram is drawn by only circles, then it can't illustrate when there are more than 4 sets in the Venn diagrams. So when there are more than 4 sets in the universe set, then Venn diagram should introduce another shape of circles to another shape of set to illustrate its shape in the Venn diagram. How many vertices and edges does a line segment have? A square, a cube, tesseract. I don't know what tesseract is. Sorry, tesseract. What is tesseract? Can you conjecture a formula for the number of edges and vertices for an n-dimensional hypercube? Can you give a coordinate of the vertices of tesseract? What would the longest length between two vertices be? So there are one edges. I don't know how to define. Just honestly, I don't know how to define edge, vertices, or plane exactly. But in my guess, a line segment will have two vertices and one edges, and the square must have four vertices and four edges, and the cube has 8 vertices. A cube has 8 vertices and 12 edges. So what are we doing? So for tesseract, it means that we have to add one more axis. But I believe that I just guessed that. So let's go back to the 0 dimension. That would be a point, and there would be one vertices and no edges. So that means vertices grows exponentially, base of 2 with base of 2, and that means for tesseract, as it is as I heard of, it is a fourth dimensional object, which gives cube as the same way as the cube gives the square on its side, on its edge. That means it will have 16 vertices. What about edge? 0, 1, 4, 12. So 0, 1, 4, 12. Why did it become 4? 1, 1, 2, 1, 2, 1. So connecting all vertices, that means 2C2, 4C2, not 4C2. It's not like something like connecting all the edges, but adding some. When it moves, when the line segment moves, it becomes twice, but there it will be added by, there would be more 2 edges as there are 2 vertices, right? And when square move, it will make 4 edges with 4 edges, additional 4 edges, but it will also make 4 edges more, as it has 4 vertices. So for e to the n equal 2 times e to the n minus 1 plus v n minus 1. I believe so. So for n equals 1, it was h was 0 and vertices was 1. So there is 1. And for n equals 2, there would be e to the n minus 1. So 2 plus 2, 4. And 3, 8 plus 4 and 4, 24. So there would be 30 edges. So now we know that vertices would be vertices would have to n minus 1. So 2n plus 2 to the en minus 1 equals e to the n. Thus, we have that we can say that e2 minus e1 equals e1 plus 2 to the n. e3 minus e2 equals e2 plus 2 to the 2 squared, 2 cubed, and what the fuck? Yes. So e fourth minus e third equals e third plus 2 to the fourth, and so on to en minus 1 equals en minus 1 plus 2 to the n power. And if I add all of this, then I'll have e1 will remain, but I'll have nth equals minus e first equals the sum of ei, where I is from 1 to n minus 1, and that equals to plus sum of 2 to the power 2 raised by the power of I, which is from I equals 2 to n. And we can just say that I equals 1 to n minus 1 to make it similar, and 2 raised by the power of I plus 1. So now I don't know how to do what. I don't know what to do more. So E1 equals 1. So En equals 1 plus e1 to a sum of e1 to en minus 1 plus the first term of the geometric curve progression is 2 squared, and there is n minus 1 terms, 2 to the n minus 1 over, as the common ratio becomes 2, so 2 minus 1. So this is the equation, and I don't know what to do more here. So again, sum of from e1 to en minus 1 and plus 2 raised by the power of n plus 1 and minus 3. What to do more? So we now have e and equals e1 plus e2 plus e3 plus and so on to en minus 1 plus 3 times 2 raised by the power of n plus 1 minus 3. And let's just observe first. E1 equals E1. E1 equals 1. E2 equals 1 plus 2 to 2 to the third minus 3. E3 equals 1 plus 1 plus 2 to the third, 1 plus 2 to the third minus 3 plus 2 to the fourth minus 3, 2 to the fourth minus 3. Let's say that it was just 0 plus 2 to the 2 minus 3. Yes. So 0 plus 2 to the 2 minus 3 plus 2 to the 3 minus 3. And then E1 becomes 0 plus 2 to the 2 minus 3 plus 0 plus 2 to the 2 minus 3 plus 2 to the 2 to the third minus 3 plus 2 to the fourth minus 3. And then what should you do? Then we can find that zero plus 2 to the 2 squared minus 3 will be added n minus 1 times. So that means once more. So e to e fourth is 0. E1 plus E2 plus E3 and E2 to the fifth minus 3. What does this tell us? So how many are there E1? How many are there E2? I mean, how many are there 2 to the squared minus 3? And how many are there would there be e to the e cubed minus 3? 2 cubed minus 3. And how many are there 2 fourths minus 3? How many are there 2 fifths minus 3? Wow. So there will be 1. There will be 1. E1 plus E2. E1. 1. E1 plus E2. But E2 also have 1. E4 will have E1, E2, but which have 1, and E3 will have 2. E5 have 1 E1, 1 E2, which have 1, 1 E3, which have 2 of E1, 4. And then E5, if E6 will have E1, E2, which will have 1 of E1, and E3, which will have 2 of E1, and E4, which will have 4 of E1. It's E5, which will have 8. So it looks like just for E1, 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2 plus 1 plus 1. Yeah, it goes on and goes on and goes on. Like, so 1, 1, 2, 4, 8, 16, and so on. And I'll add this until it becomes n minus 1. So E6, E1, 2, 3, 4, 5. E5 will contain E5 would contain E5 would contain 8 E1, 8 numbers of E1, and that means En minus 1 will have 2 to the n minus 3 number of E1. What about E2? So, but it's not E1 actually. It's actually 2 squared minus 3. There would be 2 squared minus 3. And for E2, I mean 2 cubed minus 3 will be added once and when E2, and once in E3, but not 1 here. Two, 4, 16, 8, and so on to 2n minus 4. And 2n to 4 minus 3 will comes up 1, 1, 2, 4, and 2n minus 5, and so on. So 2 n minus 1 to n to en minus 1. En minus 1, it comes up to the n minus 1 minus n, right? That's right. Plus this one. But 1 should be equal to, let's consider 2n minus 1 minus 1 first. So it will be 2n minus n minus 1 plus 1. Yes, that equals to 1. Right? But n minus 2, n minus 1 minus 3 should appear how many times? Once in an minus 2. But it should comes up twice. So it must be like 1, 1, 1. So this would be starting from first term, it would be 1, and there would be n minus 3 terms. So 2n minus 3. No, n minus 2. And 2n minus 2 minus 1 over 2 minus 1 plus 1. It is 2n minus 2. That means 2n minus 3 minus 1 over 2 plus 1 equals 2n minus 3. So I'll have to add all of this, like from 1 to 2 squared, 2 cubed, 2 to the 4th, and so on to, yes, no. And I must times 2 squared minus 3 here, 2 cubed minus 3 here, and 2 to the n minus 3 here, 2 n minus 1 minus 3 here, and so on. That will give us 2 raised by the n minus 3 times 2 raised by the n minus 2 power. So there would be n minus 1 number of 2 raised by the power of n. So n minus 1 times 2 raised by the power of n, and 3 times 2 minus 1, starting from 2 and minus 1, because there are n minus 1 terms, minus 1. This will give us n minus 1 times 2 raised by the power of n, and minus 3 times 2n minus 1 plus 3. And this would be the en. Is it right? the number of edges. No. And this result is easily obtained if you consider the number of edges which coincide at given vertex. Really? So, then 4 times to 832. They have different. Ah. If you consider the number of edges which coincide at a given vertex, it is just the number of dimensions, and each edge has 2 endpoints. Origin, longest diagonal, have length 2. TBO's problem solving booklet. Okay, so let's consider this.
Welcome back, and thanks for joining me today. If we take a happy little and we get a bit out of the board and Mr. Cube to the 4th dimension, I've drawn a cube diagonally shifted and am connecting up all the points to draw a 4D hypercube, or at least a drawing of one, done by a 3D creature on a 2D chalkboard. I might miss some lines, but that's okay. No mistakes in math, just happy accidents. Welcome back, and thanks for joining me today.
Yeah. So I made a mistake here. It's all right. So the question is, I want to prove that n times 2n minus 1 equals 2 times n minus 1 times 2n to the 2 raised by the power of n minus 2 plus 2n. Is this right? N minus 1 here. No. It's right. And with n minus 1. But, so n minus 1 minus 1, 24 plus 8, 32. N minus 1. So it will give me 2n. So n minus 1, 2n minus 2 plus 2n minus 1. It's obviously n times 2n minus 1. So why? So the vertices can move here, right? Times 2. Why is this so? Why is this so? I don't know why. I can't figure out why. And it goes to one direction, and it goes two direction. It's like duplicated, and then there one more direction I can find. They should be. What should they be? Yes, but G. Right. Right. Well, who is G? Who is G? Oh, I think the constant is. Yes. E2, E1, E1. Right. 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 Oops. So it had to be 1, 2, 3, and minus 1 here. So it had to be like this, and here should be 2, right? So 2 to n minus 1 minus 2 plus 1, so minus 1. But how can we prove this more efficiently? Is there any way to prove it? Okay, recurrence relations and right. Okay, this is not one.
Okay, so welcome to the second STEP Support Programme webinar on problem solving for maths interviews. I'm going to start today by talking a little bit about some of the questions that were asked last time. So we've been asked quite a lot of questions about STEP. These webinars are not aimed at helping with STEP. We will answer some of your questions, but I just want to point out that we had a webinar last February on STEP and how to prepare for STEP. We are intending to run the same webinar again, or a similar webinar again, but you can look at the recording of the last webinar, and I'm going to show you where you can find that. So if you go to the STEP Support Programme website, which is a bit tiny, let's try and make it a bit bigger, and if you go to events, just on this bar here, there's a tab for webinar recordings. So if you click on webinar recordings, you'll get the recordings from this webinar series, but then directly underneath that, we've got preparing for STEP. And if you go into this webinar, you'll see what we said about STEP last time. So if you've got any questions about STEP, have a look at that webinar first, and hopefully that's going to answer some of your questions. And like I say, we will have another webinar after Cambridge Offers go out, when we'll talk a little bit more about STEP. And we'll also talk a little bit more about actually sitting the exam and some of the things that you need to be aware of. So that's a bit of an advert, but also that's there for you. Some of the other things I'm going to say about the website, once I've got it up, is that there's something called the Advanced Problems in Mathematics book. So that is this link down the side here, so underneath useful links. This is written by Stephen Siklos, who ran STEP from 1986 to 2019. He wrote lots of the original STEP questions. So the first 10 years or so, most of the questions were ones that Stephen wrote. And for 30 years, he was basically the person behind STEP. If you have a look at that book, the first few questions are about sort of step 1 level, and they've also got lots and lots of discussion about how you might attempt these questions, what the thought processes are. So I think that's quite a good book for starting off with now and doing the first few questions as interview preparation. We also have work solutions to STEP questions for everything from 1996 onwards. So if you're doing old step 1 questions, not the very old ones, but 96 and onwards, you can find work solutions following this NEI link down here. Now, they're not perfect work solutions, and they're all handwritten, which can be a bit hard to read, but they're there for you if you want them. The other thing I'm going to point out, whilst I've got the website up, is we do have some notes to help you. And there are some notes in different places. So firstly, if you go to the step 2 calculus, so some top tip specification, a question, and also where you can find the webinar, you might like to have a look at those. So that was just a little bit about questions on STEP, and also where you can find the webinar recordings. We had quite a lot of questions about what happens at particular colleges. Now, there's about 30 Cambridge colleges. I can't remember what every single college does, and if I did try and remember, I'd probably get it wrong. So my advice is, if you are being interviewed at a particular college, you go to their college website and look for what information they have. So, for example, you could search for Churchill, Cambridge maths interviews and see what the information is you've got there. So have a look at actually the college you're applying to and see what they are saying. Yeah, Google's a wonderful thing, but I'm not going to sit here and try and remember what 30 different colleges do. I'm afraid that's your homework. Pre-interview tests, we had lots and lots of questions about pre-interview tests. There's 2 sorts of different types of pre-interview tests. One is the type where you do the test, but you take it straight into the interview, and one is where you have a test a few days beforehand, or possibly a couple of weeks beforehand. I think for a lot of these pre-interview tests, things like working through TOMUA, which is the test of mathematics for undergraduate admissions. If you want to find it, it is called TOMUA. So have a look at some of those questions because they can be of a similar sort of level. You can also have a look at some maths questions, again, similar sort of level. And I've been looking back at our feedback that we had from our first years when we sent out a questionnaire, and they suggested that maybe looking at some maths challenge questions or possibly kangaroos, which is the second round after the maths challenge. So another way of using sort of material that you will have covered in a slightly more tricky situation. I can see we've got some questions that have come back in again about what if you have not covered a topic. If you've not covered a topic and you know you've not covered a topic, then do say, I don't think I've covered this, or I'm not quite sure what that means. It's absolutely fine to say that to the interviewer. So most of the time we try and keep our questions so that they're based on sort of the first year of A-level studies. So we won't ask questions about hyperbolic functions, which is second year further maths. It's absolutely fine to say that to the interviewer. So most of the time we try and keep our questions so that they're based on sort of the first year of A-level studies. So we won't ask questions about hyperbolic functions, which is second year further maths. We probably won't ask that much about complex numbers or matrices, because they tend to be covered in further maths as well. I can't quite remember what's in the second half of A-level, but some of the more tricky integration stuff we'll probably not ask. So we try and keep it to a relatively small amount of information. It might mean you get asked questions which are all GCSE questions. Perhaps they involve circle theorems or prime factorisation information. It might mean you get asked questions which are all GCSE questions. Perhaps they involve circle theorems or prime factorisation. So you might be asked questions which are not included in any A-level stuff at all, so that we know that probably everybody has met circle theorems before, or perhaps everyone's met a bit about prime numbers. So we will try to ask some questions sometimes which do not rely on any A-level information. And when I say A-level, I'm also including IB, Scottish Highers, everything else. I'm using A-level as a catch-all for what you're studying at the moment. We had an interesting question, which was, is it better to be quick or better to be careful? I'm going to come back to that question in a minute. I would say generally it's probably better to be quick. So if you're expanding things out and you get a negative sign in the wrong place because you're doing it quite quickly, the interviewer might just say, are you sure about that bit? But the interviewer is fairly sure that you can expand brackets or something. If you are expanding two brackets and you do it in a very long-winded way, very, very carefully and methodically, first of all, you're not going to get onto the sort of the interesting part of the question. But also the interviewer might think that actually you're having to spend this long on doing it. And I'll give you an example in a second of the sort of thing that I mean. We had a few questions about special circumstances. If you have declared special circumstances in your application, then the college will be taking those into account. If you have any special circumstances that you're not sure that the college is aware of, then email the admissions office for the college that you've applied to. So special circumstances, talk to your college. If they already know about it, they will be taking them into account. And the last thing I wanted to talk about before we move on to some maths is the winter pool. So you'll notice last time that quite a few of our mentors, or more than one of our mentors, is now at a different college to the college that they were interviewed at. Now, because of the Cambridge college system, the applications can be a bit lumpy. So some years you might get one college that has many more applicants than they normally have. For some reason, lots of people apply to that college, and some other colleges might have fewer applicants. Now, we don't want to say, okay, that college has got far too many applicants, we were going to shove some of them off to somewhere else. We want everybody who's applied to that college to have the chance to get into that college. But what the winter pool does, it gives us a chance that if a college has got loads of really good people and they just don't have spaces to make offers to all of those good people, they can then put those people, they can say, right, these people are really good, normally we would have given them an offer, we can't do it this year, they put them into a pool, and then the colleges that have fewer applicants can have a look in the pool and then can make them an offer. I think it's normally about 20% of people end up at a college other than the one they applied to. I'm not entirely sure about that figure, but I think it's about 20%. And the key thing is that everybody who ends up in a different college ends up really liking their college. So it's nothing to worry about. It's just to make sure that everybody has a fair chance of getting in and that you don't end up being disadvantaged because you happen to have picked a really popular college that year. There's also something called the summer pool, which is much smaller. So the summer pool is when results come out and there might be a little bit of making offers to different people at that point. One thing I do want to talk about is something called the August reconsideration pool. So this used to be called adjustment, it's now called the August reconsideration pool. What this means is that for some people, so there aren't many people who this applies to, but for some people, if you were interviewed at Cambridge, but you didn't get an offer, but you actually end up getting our standard offer, then you will be reconsidered for a place in that August pool. So these are UK state school students only. Normally they have certain widening participation flags, as we call them. And we want to give people a chance to, perhaps they didn't perform as well in the interview because they haven't learnt everything, but by the time they've got to the end of year 13, they're doing really well. So next page, I'm going to just clear my drawings.
three lengths of triangle are in geometric progression. Find the possible values of R. So I want it to be A, the smallest term, and as all of them, including the common ratio, should be positive. So I'll just take a positive value A, and the others take AR and AR squared. Then and let's say R is greater than 1, because even if R is even if the common ratio is smaller than the common ratio of the geometric progression is smaller than 1, then we can consider that the common ratio as 1 over R. So it doesn't matter, even if we just set R is just the R is greater than 1. So yeah. So now we can say that AR squared is the longest. So that means AR squared should be less than A plus AR, and we know that A is positive, so we can divide each side of the inequality by A, which gives us R squared is less than 1 plus R. So it might be an equality. No. It might be quadratic inequality, which will have R squared minus R minus 1 is less than 0. So that must be that must have R should be between what should I do? 1 plus minus root 5 over 2. Yeah, but 1 minus square root of 5 over 2 is negative. So R should just be greater than 0 but less than 2, greater than 1 but less than 1 plus square root of 5 over 2. But the common ratio can be upside down. That means that could be reciprocal could be considered. So 1 plus 2 over 1 plus square root of 5 can be considered as well. So that also means that R should be between square root of 5 minus 1 over 2 and square root of 5 plus 1 over 2. And A doesn't matter, as A is just a factor that determines the size of the triangle. That means if R is determined, then A is just all of the triangles with and A will be similar triangles. So that doesn't matter, as similar as they will be determined, and they will be they could become a triangle anyway.
I asked you to have a think about this question, and I'm going to start talking about this question a little bit as if it was an interview question, and talking about some of the hints that you might be given. So the question says that 3 lengths of a triangle are in geometric progression. Find the possible values of R. It is perfectly okay to say in the interview, I'm not sure what geometric progression means, or I don't think I've met geometric progression, or could you explain to me what geometric progression means? That is all absolutely fine. So if you haven't met a term, ask what it means. So you might have asked that, and the interviewer might say it means that the 3 numbers are multiplied by the same each time, or they might be even nicer, and they might say, okay, it means that the 3 lengths have the form A, AR, and AR squared. So there could even be that kind and tell you what the 3 lengths are. Okay. Now try and imagine that you're stuck and you don't know what to do. So the interviewer might say, okay, can you tell me anything about R? And going back to our last webinar, it is better to say something stupid, rather than saying nothing at all. What you might say is, okay, well, I think R must be positive because you can't have a negative length. And that is a perfectly good thing to say and is a useful thing to say. So just saying, okay, R has to be positive is great. You've narrowed it down a bit. You've got rid of some values. So best to say something stupid than nothing at all. Perhaps now you're still not quite sure what to do with it. The interviewer might say, okay, can you think of the value of R for which this works? You might need more hints. The interviewer might say, okay, what happens if R equals something? So for a value of R that works, you can say, okay, well, if R equals 1, I get A, and A. Okay, that's an equilateral triangle. I know that works. The interviewer might say, okay, what happens if R equals 2? Okay, well, then the lengths would be A, 2A, or 4A, and actually you can't have a triangle with lengths 4A, A, and 2A because they don't meet up. Now, at this point, the interviewer has given you a hint for how to do the rest of the question, because by thinking about R equals 2, you've then worked out, okay, R equals 2 is not possible, and you now start to think about what's possible and what's not possible. So I'm going to stop talking about what an interviewer might do and what a candidate might do, and we'll actually have a look at doing this question. One of the things that is you could say, which is actually a really good thing to say, is you could say, okay, because similar triangles are just enlargements of each other, I actually don't care what A is. So instead of considering these three, I can consider 1, R, and R squared. So you spotted similar triangles, you know that this problem reduces to these lengths instead. And then if R is bigger than 1, R squared is bigger than R is bigger than 1. So R squared is the biggest side. So for these to be 3 lengths of a triangle, you have to have the longest side is shorter than the sum of the other 2 sides. And then this becomes an inequality question. So this is where the link was with the last session. So R squared minus R minus 1 less than 0. You can plot this. It looks a little bit like this. And then you can work out, okay, R equals 1 is about here. You can work out these points. And this point happens to be root 5 plus 1 over 2. I think my favourite way to solve this one is to actually use completing the square because actually it's just so much nicer. So R has to be in this region. Now I won't do the rest of the question, but when R is less than 1, instead R squared is the smallest one. So in this case you have to have 1 is less than R squared plus R. Word. So if you actually think this question. Okay, I'm going to talk very quickly about calculus and then I'm going to stop for a bit and we're going to add.
1시까지만 딱 쉬겠습니다.
actually answer some of your questions. So in a similar way to the last webinar, I'm going to have a Q&A break, sort of half an hour, 45 minutes in, and then a Q&A break at the end. So there'll be 2 breaks for Q&A. Okay, so a little bit about calculus. A lot of the time, you'll get calculus within a curve sketching question. Now, we're going to talk a lot more about curve sketching in the next webinar, but just bear in mind, calculus and curve sketching go hand in hand. But you might also be asked to do some integration. You might be asked about something involving integration as an area. So you might be asked to find something like, well, you probably won't because this is actually a step question, but theoretically, you could be asked to find the integral between 0 and 3 of floor of x. Now, floor will be explained to you as what it is, and one of the questions I'm going to suggest that you do is about the floor function. So you might be asked to do some integration in terms of areas. You could be asked something about differential equations, depending on how the question is laid out. Probably the most obvious way that you might do calculus, though, is optimization. So you might be asked to find a maximum of something or a minimum of something. And I've got a question which involves that, which hopefully I'm going to have time to talk about towards the second half of the webinar. So lots of curve sketching, but you could also do some integration or some differential equations or some optimization. We don't expect you to know everything. So there might be things that you don't know. But if you do know them, we're going to expect you to be relatively fluent in what you do know. So I'm just going to, have I got more space on the previous page? Yeah, I'm going to use this page here because I've got some writing space. So what I mean by being fluent in what you know is perhaps as part of a question, you're being asked to find the derivative of sine of x squared. So, okay. So you might be asked to find the derivative of this. You might say, oh yes, it's the chain rule. And then you write, okay, let u equal x squared, let y equals sine x squared, which equals sine u, then dy by dx equals dy by du, multiplied by du, there's nothing wrong with this, by the way, equals, get on that now, cos u multiplied by du by dx multiplied by 2x equals 2x cos u equals 2x cos x squared. So you might do that. That's an awful lot of steps. What we probably would expect, if you say, oh yes, the chain rule, I know how to do this, is we expect you to do something instead, more like differentiate inside the brackets, that gives me 2x. Differentiate outside the brackets, that is cos. Okay, that's my answer. Just do something instead, more like differentiate inside the brackets, that gives me 2x. Differentiate outside the brackets, that is cos. Okay, that's my answer. So that's the sort of thing we might expect, rather than the laborious showing every single step. It might be that if you're doing it in your head, you say, okay, so differentiate inside the brackets, that's 2x, sine x squared, and then the interviewer would say, are you sure about that? Which is kind of a clue for you've done something wrong. So are you sure about this? And you look at it and say, actually, no, that's not sine, that's cos. Which is also absolutely fine. But this is what I kind of mean by we're expecting you to be fluent. We're expecting you to be able to use things like, if you know the chain rule, we're expecting you to be able to use the chain rule without a lot of fuss. I've already mentioned that there are notes available on the Step Support programme about calculus. The other thing I would suggest you have a look at are the foundation assignments 20 to 25. So these ones you can find under foundation modules, which is helpful. Number 20 is down here. And if you look at assignment 20, which is a bit small, it's a little bit about differentiation by first principles. So the warm-ups for those 6 assignments help show where some of the rules come from, and just gives you a little bit more experience in calculus. Explains where the chain rule comes from, explains where the product rule comes from. So those are quite a good few questions to have a look at. If you haven't met first principles, it's actually a really nice thing. And I'm going to just go back to my web page. So the idea of first principles is that if you take chords, so if you draw a line between 2 points on the curve, and then you move it so that this point gets closer and closer and closer to the first point, then the gradient connecting those 2 points gets closer and closer to the tangent. You can get to this GeoGebra page from the Step Support programme, calculus notes, I think. I meant to put it in the email that's going to come out after the session. I forgot to put that in here. But that's the idea. And the formula for this, let's see if I can actually write on top of this page. I think I probably can. Is that f dashed of x is the limit, actually I'm not sure about writing equals for limit, but we'll just go with it, of f of x plus h minus f of x over h. And the reason that works is that this distance here, or actually this point here, a, is at x, f of x. This point here is at f of x plus h, x plus h, f of x plus h. So the difference in the y values is f of x plus h minus f of x. The difference in the x values is x plus h minus x, which is h. So this thing here is the gradient between of the straight line joining these 2 points. So it's the y distance over the x distance. So the question I'm going to look at is find the derivative of f of x equals 1 over x using first principles. So I'm going to write down the formula that I had a second ago. Limit as h tends to 0 of f of x plus h minus f of x over h. Sometimes it's a really good idea to actually think, do I know the answer already? Okay, well this is x to the minus 1, so if I differentiate it, I get minus x to the minus 2. So I know that's what I'm aiming for. So if I look at this limit, I get 1 over x plus h minus 1 over x over h. Now I've got to do a little bit of manipulation. We'd expect you to be relatively fluent with moving things around. So limit as h tends to 0.
So the definition of the derivative is limit as h tends to 0 of f of x plus h minus f of x over h, and that equals to limit as h tends to 0 1 over x plus h minus 1 over x over h, and we can get I think we can get limit as h tends to 0 of h x h x plus h divides x minus x plus h, and that equals to negative limit h tends to 0 of x plus h divides 1, and this will goes to h will goes to 0, so it will be negative 1 over x squared.
I'm going to put this over h at the front as a separate fraction, and then here this is equal to x over x plus h minus x plus h over x plus h. So I've taken this 1 over h out to the front, and then I have a common denominator. This then equals the limit as h tends to 0 of 1 over h into x minus x plus h is minus h over x plus h, and then these things cancel. So we've got the limit as h tends to 0 of negative 1 over x squared. And I'm write this as x squared plus xh. And actually, as h tends to 0, this bit tends to 0, so we end up with minus 1 over x squared, which is what we thought it was going to be, which is nice and reassuring. There's a question that I'm going to give you to think about, which you now can't see, so I've just shoved that all on top of it, which is the finally derivative of root.
Okay, so limit of x plus square root of x plus h minus square root of x over h, and as h tends to 0, and if I rationalize both the numerator, I'll have h on the numerator and h times x plus square root of h, x square root of x plus h plus square root of x on the denominator, and h tends 0, and we can cancel out h, both denominator and numerator, and then we will have root x plus root x divides 1. That would be 1 over 2 times the square root of x.
X, using first principles. And I'm going to give you a hint, which is rationalising. So have a go at using first principles to find the derivative of root x. And it is quite a neat little problem which tests your ability to deal with square roots. I've talked a bit about the chain rule. You might expect it to, it might be useful to know the product rule as well. If you haven't met the product rule, I wouldn't worry too much about it. The chain rule is probably more important. But if you know those two, then make sure that you are fluent in them and you're confident with them. I haven't mentioned the quotient rule because the quotient rule is basically the product rule again, but it's a combination of the product rule and the chain rule. It's not really the second rule, if you like, but you can use that one if you want. Okay, first Q&A break. Okay, mentors, any questions that you've found so far?
Yes, if I just may step in. There's one question where somebody asked whether they should study just the step 1 material for interviews, whether they should look at topics that will be on step 2 and 3. And that was upvoted quite a lot. So,
what would be your answer?
So my answer to that is, I think the interview problems are designed to be quite simple in the sense that they require usually minimal content in order to do. That's not what makes them tricky. I think what makes them tricky is that, first of all, it's the time pressure, and also they're very much, they're trying to get you to think in a way that's slightly different from maybe the way that you're used to. So in terms of content, I wouldn't be that worried that you don't have the necessary content in order to do the problem. So I definitely say shouldn't really be trying to study anything above step 1 level content.
Yeah. And even some of the step 1 questions might have aspects which are further than you need.
Yes.
Yeah, the other thing you can do is go to the STEP database and search for C1, which theoretically pulls out the STEP questions which don't need a lot of maths. Any other questions that mentors have picked up on?
There's one about knowing advanced content. I'd say not to worry about that. If the interviewers are going to introduce something that's not from A-level, they're not expecting you to have seen it before. They want to see how you approach material that may be unfamiliar to you. So don't worry. We didn't learn Fourier partial differentiation until this year, and we're all in second year. So really do not worry. If your friend notes that, awesome for them. But also, how well do they know that? We don't know that either. So don't stress that they know something you don't. They're not looking for your knowledge beyond A-level. They're looking for how you approach and tackle problems. And to be honest, having not seen it before might actually mean you can show yourself in a better light. So really don't stress about it.
Yeah, absolutely. So quite often they might introduce a new idea because that means it doesn't matter what you've already covered. It's completely new to everybody, and see how well we can go with that. Any other questions?
Yeah, I saw one. What happens if you don't manage to do any of the pre-interview questions? So I didn't do a pre-interview test, so I don't really know what the difficulty of the questions is like. But I'd say definitely in your degree, there's going to be times where you get stuck and you're not going to be able to answer the full question. So what they would kind of expect is just to kind of give your best go, put some thoughts down, especially if there's multiple parts to the question. You can if they've given a result, you might not be able to derive the result, but you could use the result in the next part. So I'd say, definitely still submit something and make sure that you've answered it or attempted to give your thoughts, even if you can't get the full question. And then in the interview, they'll be able to discuss it with you and maybe give you some hints or talk about it.
For those of you who are applying to Trinity, there are 3 sample pre-interview tests on Trinity's website. And actually, you might want to have a look at them even if you're not applying to Trinity, just to find some more questions. I think Churchill's got an example test as well. I think Down might do. I'm not sure about anyone else. Somebody just said, resources to prepare for the Trinity pre-interview test. Okay, first of all, go to the Trinity website and look at their tests. After that, things like math, step 1, all these sorts of things will be good practice. Okay, mentors, anything else that you want to pick up on?
Yeah. Somebody asked if they need to have math Olympiads or any of that sort. No, you don't want to.
I mean, if you were on the Olympiad team, they already know about you. Otherwise, yeah, it doesn't matter either way. Okay. Any other questions that mentors picked up on?
Yeah, I feel like there's been a fair few and a common theme, and it's people are worried about not being able to answer questions. So I'm grouping these two together, which is what's your advice for tackling a problem we're given in the interview if we have no initial ideas what it's about? And if you have no initial ideas what it's about, that might be a little bit tricky. If you don't understand anything, ask. Obviously, try and ask things specifically. If you don't understand this, you don't understand this. Like I said earlier about the geometric regressions. And if it's you just don't know the initial answer straight away, just speak about something. It's always better to try a little bit. Try and voice your thoughts, and even if you feel like they're silly thoughts, saying them is better than not saying them. And the second one, which has got a lot of likes, if we're completely stuck on a particular question because we're bad at that, right? Is it likely the interviewer's next question will be a different topic so that we can make up for it? So again, I wouldn't discount things saying I'm bad at this, I'm not going to do it. I think that's possibly a mindset that's not going to help you very much. But also, at the end of the day, the interviewer is trying to see how much you can do. They are trying to get the most out of you in this limited time span. So I would consider it likely that you will be given a chance to show what you can do in the interview. So they're not going to bash on with the same question for 20 minutes if you're clearly really struggling with it.
We try and make sure that the questions are on, or not all the questions are on the same topic. It might be that you answered two different questions and then a third short question is related to one of the other ones, but you won't be asked a whole half hour in combinatorics. Somebody said, is it good to pass comments on how a question went in the interview? For example, if you didn't see the way to solve a question initially, afterwards say, oh, I should have got that because. Yes, if you've spotted something, do say so. Just don't go on for 10 minutes about it. Yes, if you went in the interview, for example, if you didn't see the way to solve a question initially, afterwards say, oh, I should have got that because. Yes, if you've spotted something, do say so. Just don't go on for 10 minutes about it. If you spot something, oh, yes, of course that's wrong because, do say so, but keep it fairly short. Somebody said, how long are the interviews roughly? It depends on your college. So a lot of colleges will have 2 25 to 30 minute interviews. Some colleges will have one longer interview. Some colleges might have one short interview. So again, Google is your friend. Go look it up. Okay, anyone else want to pick up one more before I go and do some more maths?
Yeah, so I was going to answer the interview preparation one.
Yeah.
As well, and saying I didn't do much preparation for interview. Most of it I felt was for STEP. But if you can get someone to give you a mock interview, do. Like if you know anyone from your school who went to Cambridge or Oxford, if you know a family friend who did so, try and exploit that connection any way you can. Your school, there's a large chance your school will offer them. If they don't, try and find someone. Try and find a friend who's applying, do them for each other. It's just, even if it's not like the real thing, it will be it's just somewhat helpful to do so. And there's also another question which I thought was slightly meta in here. What is the chance the interviewer will ask a combinatorics question? I don't know, you can
I worked out, so let us know.
Work it out. I just thought that's slightly funny. I don't know what the answer is. Relatively high.
But it might be something along the lines of how many ways you've got to rank in 3 people rather than very complicated combinatorics. It depends a bit on your interview as well, on what sorts of questions they like to ask. Okay, I'm going to ask my mentors to disappear again. I'm going to do a little bit of maths, and then we're going to try and answer a whole new load of questions. Keep up voting your favourite questions as we do so. Okay, and then I need to reshare the screen. Okay, first question.
So to do this integral, I think I need to separate the interval as that could be positive, that simple. The integrand can be positive as so that means I need to do I need to factorize the integrand and to find the solutions, and I think that the integrand has solution at x equals -1, -1 and +1 and 0, right? X squared, because if I factorize it, x minus 1 times x plus 1 times x minus 2. Yes, so that means it looks like this. So x minus it would be positive between -2 and no, -1 and 1, and negative between between 0 and 1, it would be positive, and 1 to 2, it would be negative, and 2 to 4, it would be positive again. So I'll need to write it 0 to 1, and let's say it's just a f of x. So 1 to f of x with respect to x, and minus 1 to 2 f of x with respect to x, and well plus 2 to 4 f of x. And I just want to do this by say this, and antiderivative of f of x equals capital F of x. That means we have capital F1 minus capital F0 minus capital F2 plus capital F1. Yes, F1, and capital F4 plus F4 minus capital F2, and we've got negative capital F of 0, and plus 2f of 1 plus 2f of 2, and plus capital F of 4. So we just need to find antiderivative of x cubed minus 2x squared minus x plus 2, which might be x to the 4th over 4 minus 2x cubed over 3 minus x squared over 2 plus 2x plus a, but we don't need it for now. Let's just let it just 0. Let it be just 0. So so f of 0 will be 0. And is there any convenient way to do this? Well, I don't know. I just factor out. I just want to take out 1 over 12. Then as a vector, then it will leave us 3x to the x cubed minus 8x squared plus minus 6x plus 24. And I think this could be like I don't know. I just want to factorize it to make the calculation much easier. How can I do that? 1, 3. No. So just make it easier to do. How should I do that? Make it easier. Not factorize. Factorization is not we just need to make it easier. So how can I do that? So well, there's loads of things to do, but let's do this. X over 12 times 3 times 3x times x squared minus 1, and minus 8 x squared minus 1, and then we have to plus 16 here to make it the same. So it'll be like x over 12 times 3x minus 8 x plus 1 x minus 1 plus 16. Yes. So if I put put x equals 1 here, then it will become so f of 1 will delete all of this, then it will become 16 over 12, so 4 over 3. Well, just make it the same. So 16 over 12. I don't need to cancel out. What about f2? F of 2 would be 2 times minus negative 2, negative 6, so 10, 20. So 20 over 12. And what about 4? For 4, 12 minus 8 equals 4. 4 times 5, 20. 20 times 3, 60. 76. So 76 times 4 over 12. This is f of 4. So I'll have to do f1 minus f2. It'd be negative 4 over 12. So if I take times multiply 2, then negative 8 over 12. So it might be 76 times 4 minus 12 over 12. No, it wasn't 12. Negative 8, right? 8 over 12. So now I can cancel out like this. 2, 3, and 74 over 3, which might be equal to 28. So the answer is 28.
To have a look at is this question, which is an integral question. It's also a little bit a curve sketching question, so I'm kind of going a little bit into what we're going to be looking at next time. It's actually just the first part of the question, so you might like to have a look back at this set question, see actually what the rest of it was. So evaluate the following integrals. So the first thing that I'd probably do is I'd actually just consider f of x is x cubed minus 2x squared minus x plus 2. If you remember a bit from what I said last time about factorisation being your friend, and also the factor theorem being quite useful, if you look at these coefficients, if I stick in x equals 1, I get 1 minus 2 minus 1 plus 2, which is 0. Okay, I now know that x minus 1 is a factor. To get x cubed, I'm going to need x squared. If this means minus x squared, I need a minus 2x squared, so it's going to have to be minus x. Oh, this is a plus x, there we go. And I'm going to need a minus x, and I need a minus 2 there, and then minus 1 times minus 2 gives me 2, so I'm very happy with that. Which is x minus 1, and this is quite nice, this is x minus 2, x plus 1. Okay, so we now know what this cubic looks like. I'm going to be doing far more interesting curve sketching questions in the next session. And so this gives me a curve that looks something like this, where this is 1 and this is 2. And you can now see that you're going to have to do actually to get the modulus graph will look something like this. So you're going to have to divide your integral up into 3 different parts. So between 0 and 1, you just integrate this f of x. Between 1 and 2, you're going to integrate to minus f of x. And between 2 and 4, you're going to integrate f of x. So this might be a sort of relatively straightforward question. It might be one of, in an interview where you've got lots of little short ones. But basically, the key thing here is realising you've got to look at the places where it's positive and the places where it's negative. I'm not actually going to run through the numbers. If you want to have a go at this question, you can find the solutions off the MEI website, which is linked to on the STEP Support Programme website. So that's just a sort of a basic one, which you might be asked. So this is a step question from
Film star BM is sunning herself by the side of her enormous circular swimming pool at the sunning herself by the side of her enormous circular swimming pool. I didn't understand what is sunning herself, like she is laying on the sunbed and tanning and getting tanned or something more. I didn't understand, but I just thought she's just located there, the side of her circular something at a point A on a circumference, and she wants to drink from a small jug, small jug of iced tea placed at the diametrically opposite point B. She has three choices: to swim directly to B, choose theta width to run around the pool to a point, and then swim directly to X to B to run around the pool from A to B. She can run K times as fast as she can swim, and she wishes to brew her tea as fast as possible. So, I can just suppose that she went to some distance r theta. She followed alongside the circumference of circle, which has a distance of r theta, where r is a radius of the circle, and theta is the angle of that angle she turned through. And let's say that she went at that point X, she went directly to B. So if I suppose like this, all the three conditions could be observed as when r theta equals 0, then is the first case, and when r theta equals pi r, then it's a third case. So we have to know that the distance from X to B, but which might be quite easier because this is pi minus theta, and here, if I bisect angle here, then it might be pi over 2 minus theta over 2, and then the midpoint, the foot perpendicular from the center of the circle on the line segment BX, and take it as h, then the length of BH would be r cos theta over 2, half theta. So the BX, the length of BX would be 2r cos theta over 2, and AX, the chord AX, have a length of r theta. So this is a distance, and she will have let's say the speed of v at the circumference, and so she has on the pool, inside the pool, and kv at the circumference. So the time she takes would be r theta over v plus 2r cos theta over 2 over kv, and this is the time she takes, and we want to know that which theta make it much smaller where the t becomes the minimum. So we can take out r over v, then theta plus 2 cos theta, half theta over k, and we want to find the minimum value of theta plus 2 cos theta, half theta over k. So let's say let's take f of theta equals theta plus 2 over k times cos theta over 2, and then to find it, well, I can just guess how it looks like. So because it might be like theta, when theta and y here, then y equals theta would be looks like this, and cos theta, it looks like from 0 to pi, then it looks like this. So it might be like something like this, or just I don't know. Well, it seems it'd be quite this, or it could be something like this. I don't know. So we don't know. So we have to take derivative of here. So f prime theta would be 1 plus 2 over k times negative 1/2 times sine theta over 2. So that would be 1 minus 1 over k times sine theta over 2. So we can draw this like if k is greater than 1, then it would be this, right? Yeah. It's 1 over k sine theta is 1 over k sine theta, and plus 1. I don't know how it would be, but it could be like this or this or this. This everything start with 1, but it should be this or this or this. So for the most upper part graph, it is the smallest. It has smallest amplitude. That means k is greater than 1. K equals 0, k equals 1, and k is less than 1. So when k is greater than 1, then it would just increase like this. When k is 1, then it would be like this. And k is negative than 1, it would be like this. Increase, but decrease. Yeah. So the point is that she has no. So just surprisingly, it is. So to go there much faster, she have to directly go to B. No way. No way. Pi here. Pi. I don't know what would be the greatest one. but it's obvious that just going directly when k is no, I think that is quite nonsense because that put pi over there, and so wow. Will not go round the pool. Actually, edit terms then zero, and it starts from k. K is getting greater, so it might be when k is greater than 1, it's like this. It's gonna decrease, and then it'd be like this. K is smaller than 1. When k is really great. One time faster than and k goes to, and so the graph would be like here's the y equals theta, and here's the pi, the point pi, and when it start for k equals 1, it start from 2 here, 2, and it will have this the zero gradient at pi x equals pi, so this, and when k increases, then it also k increases, then the starting point will decrease like this. So this means that as k increases, it is more beneficial for her to start time she takes, and Mass decrease, I believe. So let's do this again.
95, which, as I say, was a very good year for STEP, is about the famous film star Birkhoff McLean. Actually, Birkhoff and McLean were two mathematicians who wrote some textbooks on algebra, I think it was. So there's a whole load of words here. The famous film star Birkhoff McLean is sunning herself by the side of an enormous circular swimming pool, and she wants to drink from her iced tea, which is diametrically opposite B. And the question is, she can either swim straight across, she can run all the way around, or she can run a little bit and then swim across the chord. So there's a whole load of words here to actually deal with. In an interview, you're not going to get this many words. And basically trying to work and then swim across the chord. So there's a whole load of words here to actually deal with. In an interview, you're not going to get this many words. And basically and then swim across the chord. So there's a whole load of words here to actually deal with. In an interview, you're not going to get this many words. And basically trying to work out what is the optimum strategy. So this is an optimization type question. So I've drawn a diagram. So that diagram there basically has all the information for the question. And I've also put down important, she can run k times as fast as she can swim. Now it hasn't stated that k is greater than 1. We would probably assume that k is greater than 1 because we assume that she can actually run fast as she can swim. But we're fairly happy that k is going to be positive. Okay, so what we can do is we can actually look at the particular case where she runs around to the point X and then swims straight across. I'm going to open up the chat to, if I can, so that people can put in some ideas. So what do you think the answer would be if k is equal to 1? What would be the optimum strategy? Which is an easy question, actually. So yes, that is the obvious strategy. But we know that when k equals 1, what the answer is going to be. And actually, that means that when we think we've solved the problem, we've got a way of checking that our answer makes sense. So for our answer to make sense, when k equals 1, the answer is going to swim. How about if k was 1,000? What do you think would happen? Those two data points there mean that you can actually think about whether or not your solution makes sense. This is going back to what I was talking about last time about using your whether something makes sense. Okay, let's look at the case in the middle. Let's assume the radius is 1, where 1 stands for 1, quite big measurement, because we're told it's a big ball. But let's call the radius 1, which is absolutely fine. If the radius is 1, somebody has already told me what I was about to say anyway. You might not know this, because you might not have covered this yet. But what would be this length, the arc length? Theta is in radians, by the way. We're going to differentiate because it's all covers. So lots of people have got this. So r theta, which said, okay, r is 1. So this length here is theta, all the way around here. Okay, so we know the distance that they have to run. This distance here, this is the cosine rule. So I'm going to call this d squared is 1 squared plus 1 squared minus 2 times 1 times 1 times cos of pi minus theta, because this angle is pi minus theta. So d squared is 2 minus 2. Actually, there's something we can do which is quite nice here. So cos of pi minus theta, we draw a cos graph. Cos looks like this, more or less. Cos of pi minus theta is minus, that distance is theta. My graph's got a bit bad. Cos of pi minus theta is same as minus cos theta, but we had a minus sign there. So we've got 2 plus 2 cos theta. So that minus became a plus. Actually, we do something else now. So d squared is 2, 1 plus cos theta. And again, if you make a mistake in the interview, it really doesn't matter. Yeah. If you said in the interview it's sine theta, you just get, are you sure? There's something we can do with this, which is going to make our life much nicer. We know that, because it's also 8 o'clock now, I'm going to work this out. Cos 2a is the same as 2 cos squared a minus 1. So actually, 1 plus cos theta is the same as 2 cos squared theta over 2. Now I can square root it. So d is 2 cos theta over 2. So this length here is 2 cos theta over 2. Okay. So that actually turned out to be really quite nice. I'm going to delete some of the stuff that I don't want. Okay, so now I know those two lengths. So the time taken is the distance divided by the speed. So time is distance divided by speed. So the total time is the time it takes me. Okay, well, let's say we've already got a radius of radius equals 1. I'm going to say that the swimming speed is v, meters per second, whatever it is, I don't really care. So the run speed is kv. Okay, so my time taken is my running distance, which is theta, divided by kv, plus my swimming distance, which is 2 cos theta over 2 divided by v, which is 1 over v into theta over k plus 2 cos theta over 2. So let's try differentiating. But we also have to use our brains whilst we're doing this as well. So dt by d theta is 1 over v into 1 over k. Cos differentiates negatively, and we also can get that factor of a half coming out. Now, if you wrote down u equals theta over 2, do y by dx, that's taking quite a lot of time. I can just differentiate it like that. Okay, so it looks like we have a potential stationary point, okay, which is a bit nasty. There's something else we can do before we actually go any further. And the question is, what sort of stationary point is this? So before I actually try and work out what theta is and stick it in, I'm going to actually try and think about, is this actually doing what we want? So how can we work out what sort of stationary point this stationary point is? If we find the second derivative, d squared t by d theta squared, we find out that that is minus 1 over v cos theta over 2. Now, theta is between 0 and pi. Theta is between 0 and pi, equal either side, which means that cos theta over 2 is between 0 and 1. So cos theta over 2 is positive, so the second derivative is negative, which means that our function time is bending like this. I might have forgotten to multiply by, yes, I did. Thank you. There you go, that's better. So our function is bending like this. So this point is actually a maximum. So what we've actually done is we've actually worked out where it's worst. And the minimum is either going to be at theta equals 0 or at theta equals pi. So minimum is going to be on one of the boundaries. So actually at this point in this question, you then need to think about, okay, at what point do you flip from running all the way around to swimming straight across? Okay, so the way you actually show that the boundary case is k over 2 is if you run all the way around, then the time taken, so the TR for run, the time taken is, the distance all the way around is pi over kv. So the time to run is pi over kv. The time to swim is 2, because the distance across is 2, divided by v. So those are your boundary cases. So that run time is pi, because the distance around half the circle is pi over kv, and the swim time is 2 over v. Looking at this, this seems plausible. If k is 1, we said when k equals 1, then we would expect swimming to be quicker. So I'm going to put sanity check. K equals 1, so run speed equals swim time. We have pi over v is more than 2 over v. So swimming is quicker. And that's what we said right at the start of the question. Okay, k equals 1, you swim. If k equals 1,000, so if we said that the running time is much quicker, if k equals 1,000, then this 1,000 over here means the run is going to be quicker. So these make sense in terms of what we thought of before. Where run equals swim, so where you've got the boundary case, pi over kv equals 2 over v, which means that k equals pi over 2 is the boundary. So if k is less than pi over 2, you swim. If k is more than pi over 2, you run. The interesting thing about this question is it doesn't actually depend on R at all. So no matter how big your swimming pool is, if you can run more than about 1.5 times as fast as you can swim, you run. And I think running 1.5, 1.57 times faster than you can swim is fairly normal for all of us. So I think most of us would just run around. Okay, one more question very quickly, and then we'll do some more Q&A, I think. Okay, I'll just talk a little bit.
Okay, so to compare those number, I want to make it the same. Like make the power as 1/6, then the base of that number would be 8, but the second number would be 9. So yes, it is possible for me to think of 2 to the 1/2 equals 2 to the 3rd of 1/2, 1/6, and 3 to the 1/3 equals 3 squared to the 1/6 to the 1/6. So as the second is greater, so the second is greater, pi over e. So I just want to take log to take out the exponent out of their position. So e log pi and e ln, let's say just ln, e times ln pi and e pi times ln e. So I want to compare this, and what I want to firstly do is I don't know which it would be, but let's say there is some inequality and sign. I suppose there exists an inequality sign. So I don't know which side is greater than or smaller than, but let's divide it. Let's do this by dividing it by pi times e. Then it will give us pi divides ln pi, and with the same sign, inequality sign will remain here like this, and ln a over e. So this is, so by considering y equals ln x over x, that we can conclude, and we know that e is greater than, less than pi, so we can see how the graph would be sketched, and just thinking of it. So to draw this, before drawing this, I want to consider this function as the multiplication of two functions, which are y equals ln x and y equals 1 over x. That will give me, if I drew those graphs on the same coordinates, then y equals ln x, it looks like this. Y equals 1 over x, it looks like this. So I can guess that when x is less than 1, it would have negative, and when x tends to 0 from right side, then it would tends to the negative infinity. So the actual graph, it looks like this, and it will increase a bit, but when x tends to positive infinity, then it will y tends to 0 from the upper side. So this is just a simple sketch of the graph. And I just want to know that if what the maximum value of where the maximum value of this function would occur. So that means that we have to compare. We have to take the first derivative on y equals ln x over x. That would give us x squared over 1 divided 1 plus minus ln x over x squared. So that means we would have e. We would have maximum at the point where x equals e, and that means as so ln x over x will have the maximum value of e. So for any x except for x equals e, ln x over x will be smaller than ln e over e. So that means ln e over e would be greater than ln pi over pi, and that means just naturally pi to the pi raised by the power of e would be less than e raised by the power of pi.
That was question. So the first part, you have to be a little bit careful with messing that up inequalities and things to make sure that you are doing something to both sides which still stays the same. So if you're raising something to a power, and we're thinking about raising it to the power 6, then x to the power 6 looks something like this. So if b to the power 6 is bigger than a to the power 6, then that means that b is bigger than a if a and b are positive. Okay, so when you're doing this sort of thing, you have to be a little bit careful what sort of function you use. And somebody said in the chat that x to the power 6 is an increasing function. So this is absolutely fine to do. So 2 to the half power 6, 3 to the third power 6, and x to the 6 is increasing. So that's okay. This gives me 2 cubed, this gives me 3 squared. Okay, this is 8, this is 9. Okay, so I'm going to try and do it. It's less than 3 squared. Think back to the first part of the question. Yeah. So quite often in an interview situation, if you're given two things like this, then there is probably going to be a connection. I think some people might have seen this before because some people suggested a graph that is going to solve it. Try to connect it to what you've already done. So as a lot of people have said, okay, raise it to the power of 1 over pi e. I mean, this looks really weird now. I've tried to leave sort of a bit of a gap in between them. Okay, if we raise both sides to the power 1 over pi e, we're now considering pi to the 1 over pi and e to the 1 over e. And we want to know which ones of those is bigger. Now, some people have already mentioned increasing functions.
So what I want to consider is y equals x raised by the power of 1 over x. So I just want to consider this as the composite function. Let's take, so it is challenging to draw just by sight because there is variables on the base and on the exponent both. So I want to take log first, which will give us ln y equals 1 over x ln x. So this would give us that y equals 1 over x times, so what should we do? 1 over x e raised by the power of 1 over x times ln x. And we know that ln x, 1 over x times ln x look like this shape. We can know the 1 over x times ln x graph could be drawn like this, where the maximum point would occur where x equals e and y equals 1 over e. I drew this graph on the rotated Cartesian coordinate as the image of the composite function will be the domain of the outer function. So I can draw the outer function on the not rotated Cartesian coordinates, and I'll draw y equals e to the x. And now, considering that x tends to e from 0, then x tends to e from 0, then the y value of the inner function will go to 1 over e from negative infinity. So to go from here to go there, and that means the domain of the outer function will move from negative infinity to 1 over e. So the actual image of the composite function will be from 0, not the 0, but 0 to e raised by the power of 1 over e. So from 0 to raised by the power to some value, that is e raised by the power of 1 over e. So it goes like this. I don't know how I don't know whether it could be concave or convex, but actually it goes like this. And we don't need to consider x negative or x equals 0. So the next thing is that we go to x tends to positive infinity from x equals e. That means the image of the inner function will decrease from 1 over e to 0, but not become 0. So from 1 over e to 0. So that means we will move domain, so input values of the outer function from 1 over e to 0. So the image of the outer function will move from the maximum point we just considered and to 1. So it will decrease again and tends to 0 from upper side. So this is y equals 1, which is an asymptote line, and yeah, this is the function we are looking for, y equals x raised by the power of 1 over x. So we had to compare e raised by the power of 1 over e and pi raised by the power of 1 over pi. So, and we have noted that we have acknowledged that y equals x over 1 over x has the maximum value where x equals e. So e over e to the 1 over e has the greatest value. So pi over pi to the 1 over pi would be less than e to the 1 over e.
Log x is an increasing function because it looks like this. So instead, we can actually look at logarithm of both sides. So this is 1 over pi over x log x. So 9x multiplied by 1 over x minus 1 over x squared log x. Okay, which is 1 minus log x over x squared. So we've got a stable you know, this is, but you can also double differentiate. So sometimes you can use what you know about a graph. Again, look at all the Q&A after the session and try and pick some out to cover at the start of the next webinar. So my ideas for practice are the warm-ups for foundation assignments 20 to 25. You can absolutely just jump straight into those warm-ups. You don't have to have done the rest of the assignments. You don't even have to do the whole assignment. It's just the first question on those 6 example sheets. Run you through some of the basic calculus ideas. And they also show you where they come from. The Step 2 calculus module has some calculus questions. I've suggested 4 different set questions. The first step question is an optimization question. My hint for that question is similar triangles. So it's one of the questions I was going to run through today. I decided against it because it is quite long. But it's a really nice optimization question. And as I say, similar triangles are the way to go. Then there's a couple more set questions. The last thing I've suggested is a video to watch, which is called How Hard Was My Cambridge Maths Interview? And this is somebody who'd like really good mentors to come back. Okay.
You and they ask you a question that you've seen before. What's the
Trying to make in our recordings, and then the first one here is problems, if not quite answered, and they're fine. Practice with it.
배터리 1%. 2시 40분까지 오기로 했는데. 배터리. 날씨가 너무 춥습니다. 진짜 너무 춥다, 진짜. 오늘은 총평은 아닌데 뭐 곧 마칠 것 같아서 오늘은 스텝 시험들 대비하라고 캠브리지 자체적으로 인터넷 강의 하는 게 있었는데 그거를 좀 다시 돌려봤고 유튜브에 올라오기 때문에 그걸 돌려봤고 뭐 보면서 느낀 게 좀 있죠. 보면서 느낀 게 뭐냐면 영국 학생들 같은 경우에는 인터뷰하는 시기에 Further Math 2랑 3를 완전히 공부하지 않은 상태일 수 있다. 그것 때문에 그런 것도 테스트를 하기 위해서 캠브리지에서 스텝이라는 시험을 만든 것이고 그래서 인터뷰에는 Further Math Pure 2, 3까지는 내가 너무 주력으로 공부를 안 해도 되겠다라는 생각과 그리고 인터넷 강의 오늘 보면서 조금 별로 얻을 거 없다고 생각했는데 생각보다 얻을 게 많았습니다. 일단 가장 큰 거는 이게 인터뷰 컨텐츠가 Further Math Pure 2랑 3까지는 잘 안 나가겠다. 그리고 인테그레이션 이런 문제도 복잡하게 안 나겠다. 그리고 올림피아드 문제 같은 것도 너무 어렵게는 안 날 거고 스텝 2, 스텝 3 이런 문제 같은 것도 너무 열심히 볼 필요는 없겠다. 스텝은 스텝 따로. 스텝 1까지는 봐도 되는데 스텝 1까지는 보더라도 스텝 2나 스텝 3까지는 안 봐도 될 것 같고 오히려 걱정인 거는 이제 스탯 아니면 메카닉스 이런 부분들이 나올 가능성이 높다. 물론 그것도 막 Further Math까지는 안 가겠지만 그래도 메카닉스랑 스탯 정도는 오히려 Further Pure 2, 3 이런 것보다는 나올 가능성이 높다. 그래서 지금까지는 Further Math Pure 2랑 Further Math Pure 3까지 했는데 매트릭스 같은 경우에는 별로 제일 어렵게 느껴지지만 굳이 너무 열심히 하지 않아도 될 것 같고 좀 기억만 하고 있다. 그런 것만 하고 있어야 되고 메카닉스랑 스탯 이거 아직 거의 안 봤거든요. 근데 메카닉스를 굉장히 잘하는 편이었는데 사실 내가 진짜 메카닉스는 자신이 있는 파트였는데 최근에 몇 달 만에 보니까 진짜 모르겠다. 너무 고등학교 2학년 때 내 실력보다 훨씬 안 좋은 수준이어서 메카닉스를 좀 공부를 해야겠다. 물론 메카닉스랑 스탯 자체가 별로 안 나올 가능성이 높고 그 다음으로 오늘 언급하신 게 벡터 같은 경우는 잘 안 나올 거라. 물론 벡터도 공부를 해야겠지만 그래도 메카닉스가 더 나올 가능성이 높으니까 일단은 스탯 같은 경우에는 통계 쪽으로 안 나올 거고 아마 계속 언급한 컴비네이터리 그쪽으로 나올 거여서 그쪽은 뭐 A 레벨 내가 공부한다고 해서 딱히 뭔가 엄청 얻어갈 수 있는 게 없는 것 같고 해봤자 좀 probability 그쪽에서 얻어갈 수 있을 건데 뭐 용어 같은 거면 좀 얻어갈 수 있을 것 같고 딱히 뭔가 통계 쪽은 공부를 안 해도 될 것 같은데 통계는 진짜 아예 안 볼 생각이기도 하고 그거 할 바에 다른 거 하는 게 나을 것 같아서 근데 메카닉스는 좀 봐야 한다. 특히 운동 같은 경우 힘이나 아니면 뭐 어떻게 작용하는지 그런 거는 좀 봐야 될 것 같아서 메카닉스를 좀 열심히 해놔야 될 것 같습니다. 그리고 빼놓을 수는 없는 건 내가 일단은 further math를 다 끝낸 상태로 다 끝냈고 스텝도 이제 WS를 바라놓은 상태여서 내가 가장 궁금한 거는 인터뷰에 따라서 그 질문이 달라지는지 물론 프리 인터뷰 테스트는 아마 동일하게 나갈 건데 그거는 안 그러면 조금 문제가 있을 것 같아서 프리 인터뷰 테스트는 아마 똑같겠지만 그 세컨 인터뷰에서 과연 A-레벨 컨텐츠가 Further Math Pure 2, 3를 그냥 면제하고 원래 걸 낼까? 이거는 또 알 수 없는 부분이기 때문에 그거는 대비를 해놔야죠. 메카닉스도 마찬가지고 그리고 그런 상황에서 내가 다 거의 100점을 다 맞은 상태에서 근데 메카닉스는 모르겠다. 내가 잘 못하는 부분이다. 라고 말하는 자체가 물론 그걸 공부를 안 한 사람이면 면접관이 공부 안 했으니까 상관없다. 아예 감점을 주지 않는다고 하는데 나는 이미 공부를 했던 상황에서 그거를 잊은 상태가 되고 케임브리지나 옥스포드 같은 경우에 굉장히 중요하게 여기는 게 얘가 계속 공부를 하고 있었냐. 지금 우리가 보여준 성적, 우리한테 지금 보여준 성적이 지금 당장 그리고 또 영국의 대학에 이제 왔을 때 그게 계속 이어질 것인가에 대한 거를 많이 중요하게 여기기 때문에 제가 일단 공부를 했던 부분에 대해서는 열심히 해놔야 한다. 그래서 스태티스틱스는 딱히 뭐 안 하더라도 메카닉스는 열심히 해야겠다. 자신 있던 부분인데 특히 자신 있던 부분을 못 하게 되면 너무 아쉬울 것 같고 메카닉스 하는데 한 일주일은 걸리지 않을까 싶은데 인터뷰가 한 2주 정도 남았죠 보통 2주 정도 남았는데 지금 자기소개서를 아직 한 번도 안 본 상황이고 물론 자기소개서가 딱히 중요하진 않겠지만 내가 바라는 거는 얘가 영어로 소통이 안 되구나 라는 생각을 절대로 면접관님들이 하지 않을 수 있도록 사실 영어로 소통이 안 되죠. 제가 영어로 뭔가 말하는 게 지금 아예 불가능한 상태인데 거의 면접관님들을 속일 수 있을까 그런 마음가짐으로 열심히 좀 해놔야 될 것 같아요. 그래서 적당히 자기소개서랑 그리고 뭐 내 상황, 면접에 관련된 것들은 특히 뭐 수학을 왜 좋아하냐, 뭐 이런 상투적인 것들이죠. 아니면 자기소개를 해봐라. 아니면 뭐 지금 긴장되지 않니? 뭐 이런 사소한 질문들에 대해서도 다 준비를 해놔야 될 것 같고, 다른 부분들 이제 메카닉스나 pure mathematics 같은 경우에는 다 해야 된다. pure mathematics 같은 경우에는 제가 보기에는 너무 어렵게 가진 않을 것 같아요. 너무 어렵게 가진 않을 거고 문제 자체는 뭐 프리-인터뷰 테스트 빼고 그냥 세컨 인터뷰에서는 아마 문제 자체는 조금 평이할 거다. 평이할 건데 물론 그것도 단정지면 안 되지만 평이할 건데 그 상황을 내가 얼마나 잘 설명할 수 있냐가 애초에 인터뷰의 목적이기도 하고 그리고 내가 잘 안 되는 부분이기도 해서 그런 부분을 최대한 많이 접해보면서 해야 될 연습을 좀 해야 될 것 같고 두 번째로 올림피아드 문제 같은 경우에는 내가 이 정도까지 난이도가 안 나올 걸 알고 있기 때문에 올림피아드 문제를 보는 건 괜찮은 게 올림피아드 문제를 보고 내 생각을 말하는 연습을 좀 해야겠다. 왜냐하면 그런 상황들에 대해서 나도 생각이 막히는 그러니까 그냥 일반적으로 쉬운 문제를 풀면 이게 어떻게 풀리는 게 답안 도출까지 다 보이니까 그래서 설명이 딱 너무 쉽게 되는데 올림피아드 문제 같은 경우는 여기까지는 생각이 되는데 그 뒤로는 생각이 안 든다. 그런 부분들을 다 설명할 수 있어야 되기 때문에 올림피아드 문제는 그 정도 난이도로 안 나올 거여서 그거를 푸는 데 초점을 두는 게 아니고 내가 생각하는 데까지 어떻게 설명할 것인가 그거에 대해서 연습을 좀 충분히 해놔야 될 것 같고 그리고 올림피아드 자체가 프리인터뷰 테스트랑 좀 관점이 겹치는 부분이 있다고 들어가지고 그런 관점을 익히는 거는 좋을 것 같다. 그래서 내가 못 풀더라도 그런 솔루션들을 계속 보면서 올림피아드 like question들을 어떻게 바라볼 것인지 그거를 좀 익히는 게 좋을 것 같다. 그리고 그거를 익혀서 어떻게 표현할 것인지 뭐 아무튼 그런 생각이 들었고 지금은 한 20분 정도 남았는데 그냥 뭐 메카닉스 너무 못해가지고 지금 옛날엔 잘했는데 옛날엔 사실 다 자신 있었고 오히려 차라리 학과를 물리학과로 하면 더 자신 있을 정도로 메카닉스를 잘했는데 지금 역학 부분이 너무 약해져서 그 부분을 좀 보완을 해야 될 것 같습니다. 그리고 스텝보다는 메카닉스를 가고 그리고 MAT 테스트 같은 경우에는 일단은 옥스포드에서는 10월에 시험을 치기 때문에 그게 아마 Further Pure Math 2, 3 이 정도까지 안 갈 것 같아요. 그래서 뭐 다른 인터뷰 매트리얼스보다는 아마 Further Math, MAT 시험이 가장 인터뷰 준비하기 좋다 이런 생각이 들어서 MAT랑 그리고 뭐 오늘 몇 개 추천해 주신 것들 그리고 인강이라고 해야 되나 아무튼 웨비나에서 많이 추천해 주신 것들 그런 거 위주로 공부를 많이 해야겠다 이런 생각이 들었습니다. 총평은 오늘 그냥 여기까지로 하고 메카닉스만 빨리 하고 끝내겠습니다. Sources. Coefficient of friction, limiting value, maximum or limiting value. Motion in 2 dimensions. Connected particle. If a system involves the motion of more than one particle, the particle may be considered separately. However, if all parts of the system are moving in the same straight line, then you can also treat the whole system as I can treat the whole system as a single particle. So 2 particles, P and Q, of masses 5 kg and 3 kg respectively, are connected by a light inextensible string. Particle P is pulled by a horizontal force of magnitude 40 Newton along the rough horizontal plane. The rough horizontal plane. And there are 2 particles connected by an extensible light string and 5 kg and 3 kg. And P is pulled by Newton. So there should be friction F1, friction F2, and normal reaction N1, normal reaction N2, and they also have to be tension, which are the same. Peak stress is 10 Newton, so F1 equals 10 Newton, and F2 equals 6 Newton. So that means gravitational force and normal reaction will be cancelled out, and tension will be cancelled out for a whole system, and so the net force, horizontal net force, would be 40 minus 10 minus 6, so that would be 34 Newton leftward. And the mass of the whole system would be 8 kg. So 34 over 8 would be the acceleration. What? No, 24 over 8, which is equal to 3. That would be the acceleration for the whole system. And so net force, acceleration, net force of the particle P would be 15 as 5 times 3, and that means that F1 tension should be 15 Newton. 15 Newton. So let me check. For 15 Newton exerted on the particle Q, then the net force would be 9 Newton. So its acceleration would be 3 meters per second squared. String is light and inextensible. And string is light, inextensible, so the acceleration of the masses is the same. Light tension is the same throughout the length, and the mass of the string is negligible. But why? 말도 안 된다. 벌써 3시 반이야? 진짜. 메카닉스 문제 하나 풀었습니다. 뭐 하나 풀었고, 수학은 없었던 건 아니야. 수학은 없었던 게 아닌 게, 원래 particles are connected by a light and extensible string 이런 상황에서 그게 만약에 the string has a mass, then it have different forces on each masses or particles. 이거를 잘 이해를 못했는데 그거를 좀 수학적으로 이해를 할 수 있게 됐다. 그냥 그거밖에 없었고 문제 하나 풀었는데 메카닉스를 좀 공부를 하는 시간을 늘려야 될 것 같습니다. 메카닉스를 빨리 끝내야지. 왜냐면 이거 스태틱스 쪽에서 내가 굉장히 잘했는데 진짜 잘했거든. 잘했는데 진짜 하나도 모르겠다. 메카닉스를 자신감 있게 그냥 들어갈 수 있도록 적어도 문제가 이제 프리인터뷰 테스트에서 나왔을 때 한번 시도를 해봐야지 이런 생각이 들 수 있을 정도로. 왜냐하면 스텝에서 아예 메카닉스랑 스탯은 그냥 빼버렸거든. 완전. 왜냐면 그게 좀 거저주는 문제라고 하는데 나는 영어를 읽을 자신이 없으니까 그 상황을 완벽히 이해할 자신이 없어서 그거에 아무리 주는 문제라고 해도 내가 뭔가 하나 실수를 해버리면 이거 스텝 시간 관리 다 꼬여버린다. 그리고 스텝 메카닉스는 굉장히 좀 문제가 길어서 그래서 사람들은 전략적으로 메카닉스랑 스태티스틱스를 좀 파고 들었지만 나는 그냥 퓨어 매스매틱스로 그냥 다 파고 다 끝내버렸거든. 그런 거 치고는 잘 치긴 했지. 근데 아무튼 메카닉스를 그래서 안 본 지 너무 오래됐는데 진짜 큰일 났다. 안녕. 그래서 이제 자러 가야 될 것 같습니다. 할 수 있다. 그래, 봤던 건데 사실. 그리고 거의 만점 받았는데 못할 게 뭐 있어. 해봐야죠. 끝까지. 2주밖에 안 남았지만 끝까지 해봐야지. 영어가 좀 문제긴 해. 아무튼 빨리 자러 가야 될 것 같습니다. 한 30분 전에, 한 20분쯤 전이었나? 뭐 총평은 거의 다 30분 됐네. 30분 전에 총평은 거의 다 끝냈기 때문에 오늘은 총평 없이 뭐 느낀 것도 딱히 없고 30분 동안 느낀 거는 방금 말한 거밖에 없고 이미 느낀 점 많았던 거 다 얘기했기 때문에 여기까지만 하겠습니다. 아닌데? 고맙습니다. 수고하셨어요. 오늘 좀 시간 좀 나왔겠는데? 몇 시간 했지? 아까 좀 많이 했던 것 같은데? 8시간 20분? 8시간 20분이면 집 가면서 단어 외우면서 가면 9시간 안 되겠지만 8시간 반 정도는 채울 수 있겠다. 단어도 사실 공부 시간에 넣어야 되는 게 사실 단어는 짬짬이 외워야 되는 거 아니냐. 당연히 맞지만 단어를 짬짬이 외우지 않기 때문에 공부 시간에 넣는 게 맞습니다. 왜냐하면 공부 시간에 들어가야지 내가 봐. 단어를 안 그러면 공부 시간에 안 들어가면 안 봐. 그래서 단어로 공부 시간에 산입을 하는 게 맞다. 단어 실력이 고등학교 때에 비하면 그리고 대학생 때에 비하면 엄청 많이 늘긴 했어. 그때 너무 아는 단어가 없었던 건 맞는데 토플 준비하면서 가장 많이 느끼는 거는 스피킹도 사실 향상된지 하나도 모르겠고 토플 시험 치면서 리딩 좀 들었던 것 같아요. 리딩은 왜냐면 고등학교 3학년 때 이제 수능 끝나고 토플 준비 잠깐 할 때 리딩 막 풀어봤는데 지문 읽는 데만 막 30분, 40분 정도 걸리더라고. 물론 그때 토플은 문제수가 14개 한 지문에 그리고 문제가 좀 많았어가지고 좀 더 오래 걸리는 건 맞는데 아무튼 옛날보다는 리딩 실력은 확실히 조금 늘긴 했어요. 근데 그거는 뭐 사람이 나이를 먹으면 또 밥을 먹으면 젊을 때는 뇌에 주름이 더 생기기 때문에 당연히 지능이 상승할 수밖에 없고 어릴 때보다는 지금이 아마 최저치일 것 같긴 한데 내 인생에서 지능 자체만 봤을 때는 상승할 수밖에 없는 거고 그 상승한 지능 가지고 이제 리딩을 하니까 고등학교 3학년 때보다는 좀 더 잘하는 그 정도밖에 안 되지 뭔가 뭐 엄청 드라마틱하게 큰 차이가 있다? 이거는 아닐 것 같습니다. 그래서 뭐 그때 대학 가려고 한 것도 아닌데 그때 대학 가려고 했지만 그때 영어로 대학 가려고 한 것도 아니고 이제 가는데 다행이죠. 아무튼 영어 공부 좀 해야 할 것 같습니다. 가면서 영어 단어 좀 외우고 확실히 8시간 정도 넘기고 하루에 딱 8시간 정도 넘겨서 이제 마칠 때는 그게 있어. 조금 뿌듯한 게 있어. 내가 잘했다. 오늘은 잘했구나. 근데 막 6시간 못 넘길 때 7시간 돼야지 조금 사람이 적당히 했다는 느낌이 들고 6시간도 안 나올 때 그때는 자괴감이 너무 드는데 문제는 그게 6시간보다 더 적을 때 그게 그리고 계속되면 자괴감도 안 와. 그래서 그게 하루에 대한 현타로 오는 게 아니고 막 그 현타가 기간 전체 기간에 걸쳐서 와버리니까 축제였는데 그래서 그러면 막 되게 비관적으로 변해 사람. 너무 안 좋은 것 같아. 그래서 무조건 하루에 8시간 정도를 공부를 해야지 정신 건강도 좋지 않을까. 그런 생각이 듭니다. 아무튼 저는 집 가면서 또 영어 단어 보면서 열심히 또 공부를 하다가 빨리 자고 내일 아침에 일어나서 교회에서 있고 언제쯤 오지? 집에? 모르겠네. 언제쯤 갈 수 있을지 모르겠다. 내일 최대한 8시간 채워보도록 하겠습니다. 안녕.